Hello and good evening to everyone, guys. I welcome you all to this wonderful channel by Unacademy NEET English. Well, my name is Kar Khurshid Alam and you can also call me KK sir. Well, my dear lovely students, tell me what's going on in your life. What's going on in your life? I hope everything is going good. Before we move ahead, I want quick confirmation that if you can see me clearly and hear me clearly, let me know in the chats quickly. Let me know in the chats quickly. Let me know in the chats quickly. Am I audible and visible? Let me know in the chats quickly. Let me know in the chats quickly, my dear lovely students. Come on, you can let me know in the chats. Am I audible and visible? Okay. I believe we are live now and super excited to start today's session, which is on amines and diazonium salts. Well, my dear students, in today's session, we will be discussing this chapter in, detail, and we will touch each and everything in this chapter. And let me tell you that if you have not studied this chapter yet, don't worry, be with me. We will kick off this session very nicely. But before starting the session, I would want you all guys to simply mark the attendance by smashing the like button. And let me know how is the Josh for today's session. Let me know in the chats how is the Josh for today's session. You can put some fire emojis there and you can put some green hearts as well so that we will start this session. Come on, let me know in the chats. How is the Josh for today's session? How is the Josh for today's session? Come on. How is the Josh for today's session? Okay, that's great. Okay, so without wasting much more time, let's get going. Let's start amines first, and after that we will start diazonium salts as well. Now, here is the methods of preparation of amines. First preparation is from alkyl or benzyl halides by reacting alkyl or benzyl halides with ammonia or amines. That means this reaction is basically Hoffman's ammonolysis method. This is Hoffman's ammonolysis method. So what is this Hoffman ammonolysis method? It is simply reaction of what we call alkyl halide or benzyl halide with ammonia or amine. Have a look. Now, whenever you are having what we call alkyl halide, and it's treated with ammonia, what will happen? You know, this ammonia is a nucleophile and this alkyl halide can act as an electrophile. It can act as an electrophile. Generally, I'm showing mechanism that is SN2 reaction. That's why I will write down over here that this should be a primary alkyl halide, because primary alkyl halides are best substrates for SN2 reactions. You know that already. Now, what will happen? This N will attack this R and this X will leave as a leaving group. Now, here what will be the product? Have a look. Product will be like this. It will result in the formation of R, NH3 with a positive charge, and then this X minus will simply attract towards this positive part. So first of all, this will be formed. But When this is formed in presence of ammonia, what will happen? This ammonia will simply abstract hydrogen from this and results in the formation of NH4 positive, and then X minus will be attracted to that and it will result in the formation of primary amine and plus it is NH4X. But let me tell you, this is the actual mechanism, but we can simply write down this in one step like this. We can simply write down like this. We will write down alkyl halide. We will write down ammonia in this fashion. We will write down ammonia in this fashion. Now, after that, we will simply form HX over here. That means one bond of this R is broken, one bond of nitrogen is broken. They will form bond with each other and they will result in the formation of primary amine and HX will be formed. But as ammonia is there, if ammonia is taken in excess, this HX will react with ammonia and form ammonium halide. So this is the trick. So you can simply write down reaction in this fashion and you will remember reaction in this fashion. So from alkyl halide and ammonia, you first get what we call primary amine. Now, after that, if alkyl halide is taken in excess, primary amine will react like ammonia with alkyl halide and form secondary amine. So you will simply remember this reaction in this fashion. So now, primary amine which has been formed will react with excess of alkyl halide like this. Primary amine will react like this and HX will be lost and it will result in the formation of RNHR. That means it will result in the formation of a secondary amine. So it will result in the formation of a secondary amine. After that, as alkyl halide is taken in excess, secondary amine formed in the above step will react now. That secondary amine will react now with this alkyl halide once again, as alkyl halide is taken in excess, and it will result in the formation of a tertiary amine, that means R3N. After that, alkyl halide reacts with tertiary amine, but here no hydrogen is present in tertiary amine. Now it will simply attack this R and X minus will leave over here. So the product formation will be tetra-alkyl ammonium halide, and this is a quaternary ammonium salt. This is a quaternary ammonium salt. So can I say, whenever alkyl halide is taken in excess and treats with ammonia, it results in the formation of quaternary ammonium halide or quaternary ammonium salt via formation of primary amine, secondary amine and a tertiary amine. So that reaction during which quaternary ammonium salt is prepared from alkyl halide on treatment with ammonia via formation of primary, secondary and tertiary amine, that reaction is known as Hofmann's ammonolysis of alkyl halide. So this is Hofmann's ammonolysis of alkyl halide. Similarly, if this R is not an alkyl group, this is what we call a benzyl halide. Now, if this R is benzyl, I mean to say, if we are having a structure like this, if we are having a benzyl halide and this benzyl halide is taken in excess and is treated with, have a look, and is treated with ammonia. So we will simply lose HX over here and we will first result in the formation of this CH2NH2. CH2NH2, that means a primary amine. After that, this primary amine is further treated with this benzyl halide because we have taken benzyl halide or alkyl halide in excess. Now, it will react now with this one, H and X will be lost, so it will form. So this is the benzyl halide. Let me write down over here like this. This will be H and this H and X will be lost. So we will get PHCH2 whole 2 and NH. That means we will get PHCH2 whole twice and then NH. This is known as a secondary amine. This is known as a secondary amine. First, we get primary amine, then secondary amine. Now, after that, when this secondary amine, I mean say pH, CH2, whole 2, NH, is treated with another molecule of, I mean say benzaldehyde, this benzyl halide, another molecule of benzyl halide. What will happen? What will happen? Once again, this H and X will be lost, and it will result in the formation of, this is pH CH2, this is pH CH2 whole 2, so it becomes pH CH2 whole thrice, and then N. That means once again a tertiary amine is obtained. Then finally this tertiary amine, pH CH2 whole thrice, N, that means tertiary amine, will react with pH CH2X, I mean say benzyl halide. So it will attack on this electron deficient site, X will be lost. So it will result in the formation of quaternary ammonium salt like this, pH, then it is CH2, then it's whole 4, then it is N having a positive charge, and then X having a negative charge. So that reaction, with the help of which you can simply convert primary alkyl halide and ammonia into quaternary ammonium salt via formation of primary, secondary and tertiary amine, is known as Hofmann's ammonolysis method. If starting material is alkyl halide, then we call this as Hofmann's ammonolysis of alkyl halide. If starting material is what we call benzyl halide, we call this reaction as what we call Hofmann's ammonolysis of benzyl halide. I hope this is clear to everyone. Now, let me know in the chats, am I clear till now? Am I clear till now? This is very easy reaction. Let me know in the chats, am I clear till now? Am I clear till now? Let me know in the chats. Come on. We have to finish this whole chapter, and that too in very less time. Come on. Is this clear till now? Let me know in the chats quickly. Yes, come on. You can show some fire emojis so that I may be much more motivated. Come on. Yes, that's great. But remember one thing. You have to note down one thing. That aryl halides do not show this reaction. Aryl halides, I mean say like this, in which halogen is directly attached to benzene, do not show this reaction. Do not show this reaction. They do not show this reaction. Aryl halides do not show this reaction. Why is it so? Because we know haloarenes or aryl halides generally do not, or haloarenes do not show what we call nucleophilic substitution reactions under normal conditions. That's the reason they do not show this reaction. After that, we have another reaction, a very important reaction, that is reduction of nitro compounds. Now have a look. First, this reduction can be carried out by using, I mean say catalyst. That means first reduction will be a catalytic reduction. First reduction will be a catalytic reduction. Have a look. This is very important reaction. Whenever you are having an aromatic nitro compound or you are having an aliphatic nitro compound, whether aliphatic nitro compound or aromatic nitro compounds are treated with catalysts, say for example, I mean say if they are undergoing hydrogenation or reduction in presence of catalyst, say for example H2 in presence of catalyst. So what will be the product? This NO2 group is simply reduced to NH2 group. That means we will get aromatic amine. If this AR aromatic ring is phenyl ring, then we will get aniline, that means aromatic primary amine, and we will get aliphatic primary amine as well. Now the question is, catalysts generally used are platinum, palladium, nickel, ranny nickel, etc. So these are the catalysts. So in presence of H2PT, H2PD, H2Ni, H2 nickel. This will simply convert NO2. Yani these catalysts will convert simply in presence of hydrogen, and catalyst will convert simply NO2 to NH2 groups. I hope this is clear to each and every one. You have to remember only these amines, say catalyst and the hydrogen in presence of catalyst. That means this is hydrogenation or reduction in presence of catalyst. That is why this is known as catalytic reduction. So catalytic reduction of aromatic nitro compound as well as aliphatic nitro compound converts, forms aromatic amine as well as aliphatic amine. Let me know in the chats, is this clear? Is this clear? If I give you an example, will you say me what will be the product? Will you say me the products in the chat? Come on, let me know in the chats. Let me know in the chats. I will give you example. You have to form the product. You have to form the product. Okay, come on. Aditya Gopala, thank you very much for responding. Now, others, I'm waiting for response of other students as well. Come on. Come on, my dear lovely students. Come on. I'm waiting. I am waiting for your response. Come on. Okay. Saranya. Good. Come on. Okay. Kirthana. Nice. Now have a look. If I write down an example like this. Nitrobenzene. If it is treated with hydrogen in presence of a catalyst, generally catalysts are platinum, palladium, nickel. Now tell me what will be the product over there. And if we are, say, treating this nitroethane with same reagent, say hydrogen in presence of catalyst, what will be the product over here? What we have to do is, we have to simply convert NO2 group into NH2 group. So what will be the product over here? Nitrobenzene will be converted to aniline, that means aromatic primary amine. And this nitro compound is converted to a primary amine known as ethanamine. So nitroethane gives ethanamine, a primary aliphatic amine, and nitrobenzene will result in the formation of primary aromatic amine known as aniline. I hope this is clear. This is very easy chapter. Now let me know, is this clear? Come on. Today you have to be very much responsive. Come on. Come on. Okay. Yes, sir. Understood. Thank you very much. Nobody. Lyra. Okay. Now, come on. Another reaction is, say after catalytic reduction, another type of reduction is reduction by using active metals. Reduction by using active metals in acidic medium, say for example in HCl. So another reaction is reduction of nitro compounds by using active metals in HCl. Now, what are these active metals which are generally used? Active metals which are generally used, they are tin. And in acidic medium, that means tin in HCl. Similarly, iron in HCl, or zinc in HCl. So these reducing agent will convert aromatic nitro compounds as well as aliphatic nitro compounds to aromatic primary amine as well as aliphatic primary amine. Say for example, I will write down over here one of the active metal in acidic medium. So they will convert simply NO2 group into NH2 group. So here once again, this will be formed primary aromatic amine, and here aliphatic primary amine will be formed. That means whenever you treat aromatic as well as aliphatic nitro compounds with tin HCl, iron HCl, zinc HCl, active metal in acid, you will get simply amine, respective amine. You have to simply remove NO2 and you have to attach NH2 instead of NO2. I hope this is clear to each and every one. Now, if I will give some example like this, what will be the product then? What will be the product? What will be the product? Simply nitrobenzene and nitromethane. What will be the product over here? Nitrobenzene and nitromethane upon reduction by using, say for example, iron in HCl and what we call nitromethane in presence of iron and HCl. What we have to do is, we have to simply replace that NO2 by NH2. So the simple product formation will be like this. So here we will get aniline, that means aromatic primary amine, and here we will get aliphatic primary amine. I hope this is clear to each and everyone there. I hope this is clear to each and everyone there, because this chapter is very, very easy, and there are chances that in your NEET examinations at least 2 questions will be asked from this chapter. Now, so you have to be very much sincere. You have to be very much sincere. Now, come on. Next is reduction. Third is reduction by using, that means reduction of nitro compound by using lithium aluminium hydride. By using lithium aluminium hydride. This is very, very important. So you have to remember these things. If you are having aliphatic nitro compound in presence of lithium aluminium hydride, you can write down lithium aluminium hydride like LiAlH4 or LaH in short form. Now, whenever lithium aluminium hydride is there, it converts aliphatic nitro compound to aliphatic primary amines. That means replace NO2 by NH2. But remember, if you treat this with aromatic nitro compounds, this is very, very important. You have to remember this point. If you treat lithium aluminium hydride, if you treat this aromatic nitro compound with lithium aluminium hydride, it cannot form amine. Instead of that, it will form this one. It will form this one. For example, if this AR is C6H5, I mean to say, if this is nitrobenzene, then same reaction will result in the formation of azobenzene instead of aromatic amine. So you have to remember this. But if you are having aliphatic nitro compound, say for example this, then it's very, very simple at that time. You have to simply replace NO2 group by NH2 group. So this is the reaction of aliphatic nitro compound, and this is the reaction of aromatic nitro compound. That means aromatic nitro compound with the lithium aluminium hydride reacts in different manner. So you have to remember this. This is similar to that of this aliphatic nitro compound reacts in similar fashion like this, or what we call like this. But aromatic nitro compound results in different fashion. It results in the formation of azobenzene. I hope this is clear till now. Let me know in the chats quickly. Is this clear to each and everyone? Come on, my dear students. Come on. Show some josh. Shabash. Show some josh in the chats as well. Come on. I'm waiting. Okay, is this clear? This is clear. Okay, thanks for responding. Now, after that, you have to remember one more reaction like this. This is very, very important reaction. Whenever, that means reduction in neutral medium. Reduction in neutral medium. Reduction in neutral medium. Remember, this is the reaction which is not given on your text or in your text, but this was asked in different competitive examinations. So have a look. If you are having, I mean say aliphatic nitro compound, or you are having an aromatic nitro compound, and if this is treated, and if this is treated with zinc and ammonium chloride, that means neutral medium is this, zinc and ammonium chloride. What you have to do is, have a look, you have to convert this NO2 but into NHOH. That means hydroxylamine will be formed. Here it will be hydroxylamine which is formed. So this will be the hydroxylamine which is formed. That means you have to convert NO2 into NHOH. For example, if I write down like this, CH3CH2NO2, in presence of zinc and ammonium chloride, that means in neutral medium, what will be the product? What will be the product? Very, very, very easy reaction. Convert NO2 into NHOH. That means the product formation will be like this. It will be N-ethyl hydroxylamine. So it will be like this. Convert NO2 into NHOH. Similarly, if you are having a nitrobenzene, under similar conditions, what will be the product? What will be the product under similar conditions? Product will be NHOH, hydroxylamine. Product will be hydroxylamine. But remember, if this hydroxylamine, N-phenyl hydroxylamine, is treated with, if it is treated with Tollens reagent, like this, if it is treated with Tollens reagent, I mean say ammonical silver nitrate solution. Remember, this ammonical silver nitrate solution, that means this Tollens reagent, will simply remove this hydrogen from hydroxylamine and it will form nitrosobenzene. Now tell me, what has happened to this hydroxylamine? It loses hydrogen. That means removal of hydrogen has been taken place. Removal of hydrogen means oxidation. That means Tollens reagent oxidizes this hydroxylamine to nitroso compound, but it itself is changed to silver, and this silver will be deposited on the walls of a test tube and it will shine like a mirror, and this is known as silver mirror. After that, 4 times ammonia will be there, and as well as oxygen. Oxygen will be 2 in number. That means twice water will be there. So have a look. This Ag positive, this is basically Ag having a positive charge. Ag positive is changed to Ag0. That means here loss, what we call gain of electron, that means reduction of Tollens reagent takes place, but oxidation of hydroxylamine takes place. Have a look. This hydroxylamine has been formed from nitrobenzene. So that means this reaction is simply used as a test for nitro compounds. This reaction is used as a test for nitro compounds. This reaction is used as a test for nitro compounds. This is used as a test for nitro compounds under the name, remember the name, under the name Baker-Mulliken's test. Baker-Mulliken's test, or sometimes it's written as Barker-Mulliken's test. So this reaction can be used as a test for nitro compounds, because here silver mirror will be obtained. That means that Tollens test or silver mirror test is also given by hydroxylamines. I hope this is clear to each and every one. Let me know in the chats, is this clear? Let me know in the chats, is this clear? Let me know in the chats, is this clear? Come on guys, let me know in the chats. Let me know in the chats, is this clear? Come on. Let me know in the chats, is this clear? Akshita, sir. Bhargav, yes sir. Brintha, sir. Come on everyone. Rifka, yes sir. Okay, that's great. That is great. Okay, Bhargav, clear, sir. Thank you, thank you, thank you. Now, after this reduction, but remember, in this reduction, amine is not prepared. But as this is very, very important reaction, that's why I am giving those important reactions in this as well. Now, after that, you have to remember one more reduction. That is electrolytic reduction. Electrolytic reduction of nitrobenzene. Electrolytic reduction of nitrobenzene. Have a look. Whenever nitrobenzene undergoes electrolytic reduction, whenever nitrobenzene undergoes electrolytic reduction, it takes place either in weakly acidic medium, and at that time aniline is obtained. That means in weakly acidic medium you have to replace this NO2 by NH2. But in strongly acidic medium, you have to convert this NO2 into NHOH. That means hydroxylamine will be formed first. But this will undergo rearrangement. It will undergo rearrangement. That means it rearranges to. Rearrangement will take place. So it rearranges to para-aminophenol or 4-aminophenol. So this is para-aminophenol or 4-aminophenol. In nutshell, nitrobenzene during electrolytic reduction in strongly acidic medium results in the formation of 4-aminophenol, and in weakly acidic medium results in the formation of aromatic primary amine known as aniline. Okay. Then another reduction is selective reduction. Another reduction is a selective reduction. Another reduction is a selective reduction. Now have a look. Say for example you are having meta-dinitrobenzene. In meta-dinitrobenzene there are two nitro groups, and if you want to reduce only one, that means you have to show simply, if you want to reduce only one nitro among these two, that means you have to perform selective reduction. And that selective reduction can be done if you use ammonium sulfide or sodium sulfide or sodium bisulfide or sodium disulfide. I mean, say either with the help of sulfide or polysulfide, you can simply reduce one NO2 without affecting another. That means the product of this reaction at that time can be like this, meta-nitroaniline. And this reduction, selective reduction, with the help of which one can be reduced and another remains unaffected by treating these types of compounds with sulfides or polysulfides, this reduction is known as xenin reduction. This type of reduction is known as xenin reduction. I hope this is clear to each and everyone there. Now, so these were few reduction reactions, but these all nitro compounds cannot form what we call aromatic or aliphatic amines, but still they are very, very, very important reactions. That's why I show these reactions as well. Now have a look. One asked question which were asked in competitive exam is electrolytic reduction of nitrobenzene in strongly acidic medium produces. Have a look. This is electrolytic reduction in strongly acidic medium produces what? Para-aminophenol. So this question was asked. So directly you can write down that was para-aminophenol. After that, another question is, what is the product obtained in the following reaction? Have a look. This is nitrobenzene and this is neutral reduction. Nitrobenzene upon neutral reduction gives hydroxylamine. That means this is the product. This is once again another asked question, or this is a PYQ. That means previous year question. I hope this is clear till now. Write down in the chats. Is everything clear till now? Am I clear till now? Come on, let me know in the chats. Am I clear till now? Let me know in the chats. Akshita, thank you. Yes, sir. Kamani, yeah. Okay. Kirthana, yes, sir. Great. Evangelini. Okay, clear, sir. Clear. Okay, thank you. God bless you all. Now, after that, we are having reduction of nitriles. What is nitrile? Alkyl cyanide. What's isonitrile? Alkyl isocyanide. Have a look. If you are having nitriles, whether it's aliphatic or aromatic, have a look. If you are having aliphatic or aromatic nitriles, what we have to do is, when these are treated with reducing agents, and reducing agents used generally are hydrogen in presence of catalyst, say for example ranny nickel, and hydrogen is there, that means catalytic hydrogenation, or it is simply what we call sodium in ethanol or sodium amalgam in ethanol. Okay, now similarly you can write down lithium aluminium hydride, or I will write down lithium aluminium hydride first, then sodium amalgam or sodium in ethanol. So what will happen over here? Have a look. You have to remember this reaction with the help of trick. Simple trick. You broke one pi bond, add hydrogen here. After that, broke another pi bond, add hydrogen over here and hydrogen over here. So between carbon and nitrogen there will be one single bond. That means it will be RC single bond N. Now this carbon is having two hydrogens now, so it will result in the formation of CH2, and this nitrogen will form NH2. So whenever you are having a functional group NH2, this is known as primary amine. So if starting material is RCN, we will get RCH2NH2. That means from cyanide, nitrile, we will get what we call aromatic or aliphatic primary amine, depending upon whether the starting material is aromatic cyanide or aromatic nitrile or aliphatic nitrile. I hope this is clear to each and every one. Now, if you are having an example like this, CH3, CH3, C triple bond N. Now, what will be the product? Similarly, if you are having benzonitrile, then what will be the product? Come on, let me know in the chats quickly. What we have to do? What we have to do is break two bonds, add two hydrogens here, add two hydrogens here. Break two bonds, add hydrogen, two hydrogens here, two hydrogens here. So what will be the product? Product will be simply CH3, CH2, NH2. And here it will be simply benzene ring, with that it is CH2 and then NH2. I hope this is clear to each and every one. Now, let me tell you one more thing, that is, whenever you are reducing this cyanide to amine by using sodium in alcohol or sodium amalgam in alcohol, we call this reduction as Mendius reduction. So which type of reduction is known as Mendius reduction? In which aliphatic or aromatic cyanides are converted to aliphatic or aromatic primary amine by using sodium in alcohol as reducing agent or sodium amalgam in alcohol as reducing agent. These are very, very simple reactions. I hope these are clear to each and every one. Now let me know in the chats. Am I clear till now? Let me know in the chats quickly. Exactly. This is known as ethanamine, exactly, or ethylamine, or aminoethane. Nice. Exactly. Okay, clear, sir. Okay, nice. After this reaction, we are having reduction. We are having now reduction of isonitrile. So if you are having aromatic or aliphatic isonitrile, so this is isocyanide, isonitrile, or this is also known as carbyl amine. Remember, when this is reduced by using either lithium aluminium hydride, or you can reduce it by using H2 in presence of catalyst, say for example Raney nickel. What you have to do is, remember, what you have to do is, you have to first of all form a single bond between nitrogen and carbon. You have to simply form a single bond between nitrogen and carbon. And now we know nitrogen can form 3 bonds. It's a trivalent. Here 2 bonds are present. Now add hydrogen. Now we know carbon can form 4 bonds. 1 bond is there. So add 3 hydrogens as well. Now this is an amine having functional group NH. This is known as secondary amine. So whenever isocyanides are reduced, then they will form secondary amines. But cyanides or nitriles form primary amines. So that is primary amine, this is secondary amine. But here, limitation of this reaction is that we cannot prepare each and every secondary amine. We prepare secondary amine, only those secondary amines in which there is at least 1 methyl group attached to, I mean to say, nitrogen. So this is simply known as N-methyl amine. N-methyl, and after that this whatever will be the value of this, and after that this will be that amine. So if this is CH3, then it is N-methyl, then methanamine, yeah, what we call dimethyl amine. I mean to say, here amine will be always that amine in which one of the alkyl groups will be methyl. We cannot prepare CH3, CH2, NH, CH2, CH3 from this. Why? Because one of the amine, one of the alkyl group attached to nitrogen should be, I mean to say, methyl. So this is the limitation of this reaction, that each and every secondary amine cannot be obtained, but this can be obtained in this fashion. For example, if we are having an example of this one, CH3, CH2NC. Now, what will be the product? And similarly, what will be the product of this? What will be the product of this? Now, let me know in the chats quickly. Let me know in the chats quickly. What will be the product? You have to convert NC into NHCH3. That means our product will be CH3CH2. Now convert N into NH, convert C into CH3. So have a look. This is a secondary amine, but at least one alkyl group attached to nitrogen is methyl. Similarly, here it will be like this. So it is NH and convert C into CH3. So this is once again a secondary amine, but in this secondary amine, one of the alkyl groups should be or must be CH3. I hope this is clear. I hope this is clear. Let me know in the chats. Is this clear? N-methyl, exactly, ethanamine, exactly. And this is N-methyl, what we call, or we can simply say this is methyl phenylamine, or N-methyl, what we call benzonamine. Okay. Great. Now, after this, we have another reduction. And this is reduction of amides. Have a look. This is amide. This is amide. This is aliphatic amide. So, whether aliphatic or aromatic, what you have to do is, you have to simply treat this amide with lithium aluminium hydride followed by hydrolysis. Then you have to convert the CO, but CO should be of amide. Remember, when CO is of amide, then you have to change this CO to CH2. I mean to say, your products will be either aromatic or aliphatic, but primary amine. Now, what we have to do is, we have to change this CO to CH2, but if it is of amide. Now, let me know in the chats, what will be the product over here? What will be the product over here? So, from amide, we get primary amine. But let me tell you, this is primary amide. This is primary amide. Have a look what's meant by that. If you are having CH3, CO, NH2, this is primary amide. If you are having CH3, CO, NH, CH3, this is N-alkyl amide, or we can call this as secondary amide. Similarly, if you are having CH3, CO, NCH3, CH3, this is N dialkyl amide, or we can call this as a tertiary amide. So this is primary amide, this is secondary amide, this is tertiary amide. What we have to do is we have to simply change this C double bond O to CH2. So what will be the product if lithium aluminium hydride is used, or lithium aluminium hydride followed by hydrolysis is used? You have to convert CO into CH2. Rest remains as such. So CO has been converted to CH2. So primary amine. This is known as primary amine. Now, after that, if secondary amide is reduced, it will result in the formation of CH3, CH2. After that, it is NH, then CH3. Now have a look. This is primary amine functional group, but this is the functional group of secondary amine. That means we get here secondary amine. So primary amide will form primary amine, secondary amide will form secondary amine. Similarly, tertiary amide will form a tertiary amine group. So it will form a tertiary amine, and we have to change CO to CH2, and this is a tertiary amine functional group, hence this is a tertiary amine. This is a tertiary amine. Similarly, if I write an aromatic amide, like this, CONH2, what we have to do is, we have to change this CO, and we have to convert this amide into, amine. So it is CH2, NH2. Have a look. Amine formed from amide contains same number of carbon as that of parent amide. Amine formed from amide contains the same number of carbon as that of amide. Have a look. Now, let me know, is this clear? Let me know, each and every one. Let me know, is this clear? Okay, come on. Let me know, is this clear? Yes, clear, sir. Ruxana, thank you. Okay. Pavana, yes, sir. Thank you. Roshini, thank you. Mubina ji, thank you. Kirthana, thank you. Okay. Bhargav, thank you very much. Now, after this, we have another reaction. That's once again a reduction. And reduction of azide. What is meant by azide? Have a look. This is alkyl azide, and I will form a structure of that like this. N3 means azide. So this is N1, this is second N, and this is third one. That means total N is 3 in number. So this is known as N3 group. So this is alkyl azide. What we have to do is, this is very simple. We have to convert it into NH2. So with the help of which reducing agent we can convert this? Number one is lithium aluminium hydride, or you can use hydrogen in presence of palladium as a catalyst with small amounts of carbon on that palladium surface. Now, what will happen? You just broke this bond. When this bond is broken, this will attract electron towards itself. So N2, that means nitrogen will be lost. After that, this N forms NH2 by adding hydrogen. That means convert this N into NH2 by removing, nitrogen. So in this fashion, we will get primary amine. From this one. That means if I take an example of CH3N3, what will we do? We will simply remove 2 nitrogens, nitrogen molecule, and after that it remains CH3N. But convert that N into NH2. That means this will be the product. So this is the primary amine formed from this reaction. Another reduction is of oximes. Oxime is basically this one. C double bond N, single bond OH. It can be formed either from aldehyde or ketone. Now, if here value is H, and H, that means it is oxime obtained from aldehyde. If here it is R and H, that means once again it is an oxime of aldehyde. But if neither H is present here or here, if alkyl or aryl groups are present here, then this is known as oxime of ketone. Now, what we have to do, whether it is oxime of aldehyde or oxime of ketone, what we have to do is we have to treat it with lithium aluminium hydride, or we have to treat it with sodium in alcohol. These reducing agents will convert. What will they convert? How they convert this into amine? Have a look. First of all, this bond will be broken. Give H to this and H to this. First of all, give H to this as well as H to this. After that, break one more bond. Give H to this and H to this. So this becomes CH single bond NH2. I mean to say once again, as you know, NH2 functional group is there. So this is once again a primary amine. So whenever NH2 is the functional group, it's primary amine. Whenever NH is the functional group, it's secondary amine. Whenever it's a tertiary nitrogen, in which nitrogen is attached to three carbons on three sides, then it's a tertiary amine. So this is a primary amine. If I take a simple example here, what will be the product? If I write down CH3, CH3, that means this is an oxime of ketone. And if I write down CH3, CH double bond NOH, this is an oxime of aldehyde. Now, what will be the product? What will be the product if we treat these oximes with these reducing agents? So simple. We have to break this and add hydrogen here, break this, add hydrogen here, break one more bond, add one hydrogen to nitrogen and one hydrogen to carbon. Similarly, break this bond, add one hydrogen to nitrogen and one hydrogen to carbon. So the product will be CH3, CH, CH3. And then that nitrogen becomes NH2. That means it's a primary amine because functional group is NH2. This becomes CH3, and then this is CH and H. That means this is CH2. I will write down like this. This is CH3, CH2. So it is CH3, CH2. After that, it is NH2. So once again, it is a primary amine. I hope these reduction reactions are very clear to you. I hope these reduction reactions are very, very, very clear to you, because these reduction reactions do not need any type of, say, mechanism. You can remember these reductions with the help of these tricks, or so that you can simply answer the questions if questions will be taken from these topics in your competitive examinations. Am I clear till now? Am I clear till now? Am I clear till now? Let me know in the chats. Okay, crystal clear, crystal clear. Thank you very much. Now, after that, it's a very, very important reaction, known as Hoffmann bromamide degradation reaction. This reaction is also known as Hoffmann's bromamide reaction, simply. Bromamide reaction, simply. Or this is also known as Hoffmann's rearrangement. That means during this reaction, rearrangement takes place. So this is Hoffmann's rearrangement as well. Now, have a look. This reaction is basically either aromatic or aliphatic amides. Whenever aromatic or aliphatic amides are treated with bromine, whenever aliphatic or aromatic amide is treated with bromine in presence of either NaOH or KOH. NaOH or KOH. But remember, 1 mole of bromine will react with 1 mole of amide, but 4 moles of NaOH or KOH will be there. So that reaction will be simply like this. Reaction will be simply like this. Reaction will be like this. It will result in the formation of, what we have to do is, we have to remove this C double bond O. Remove C double bond O. That means you have to form an amine with 1 carbon lesser than that of the parent amide. That means here amine will be simply aromatic or aliphatic amine, primary amine, but with 1 carbon lesser than that of the parent amide. So we will get here primary amine, whether aliphatic or aromatic, but 1 carbon less than that of, I mean to say, starting amide. In addition to this, so this is a primary amide, but 1 carbon lesser than parent amide. In addition to this, we will get Na2CO3 or K2CO3 depending upon is there NaOH or KOH. If there is NaOH, then it will be Na2CO3, and if we take KOH, then it will be K2CO3. Similarly, plus it will be what we call twice NaBr or twice KBr plus twice H2O. Now have a look. So this is the reaction. This is basically simple reaction. Now, instead of NaOHBr, sometimes we simply write down NaOBr, sodium hypobromite or potassium hypobromite. So whether the reagents are bromine and NaOH or bromine and KOH or NaOBr or KOBr, reaction is same. It will simply convert amide into amine with 1 carbon lesser than that of the parent amide. Now have a look. What is basically the mechanism of this reaction? As this is very important reaction, so you must know mechanism once. Now what will happen over here? Have a look. If you are having CONH2, I mean to say, if you are having an amide, whether it is aliphatic or aromatic, first of all, base, say for example NaOH, will abstract this H from here, and it will result in the formation of either aromatic or aliphatic C double bond O NH having a negative charge. So it will form an amide anion over here. After this, this is treated with bromine. And let me tell you, this positive part will simply attract with this Na positive. So Na positive will attract simply this negative charged nitrogen. That means there will be an attraction between these two. Now, after this negative charge will attack one of the bromines and Br minus will be lost. So Br minus and Na positive means NaBr will be lost. So we will get this one, CO and then NHBr. So this is N-bromamide. So bromine is attached to, I mean to say, amide at nitrogen. So this is N-bromamide. So we can simply say this is one of the intermediates of the reaction. So this is intermediate first of the reaction. After that, have a look. That intermediate, either aromatic or aliphatic, once again reacts with a base. Say for example our base is NaOH. Now this NaOH will abstract this hydrogen and it will result in the formation of this amide, this anion, RCO, then N having a negative charge, and then it's Br. First of all, we must know that nitrogen is having lone pair in neutral state, and here there are two, what we call lone pairs are present in this. This is known as N-bromamide ion. That means this is an amide in which bromine is attached to nitrogen, and at that nitrogen anion is formed. So this is N-bromamide ion. Now after this, what will happen? Have a look. This bromine will be lost. So Br minus will lose, and it can result in the formation of RCO, and then this N becomes neutral. But here, this nitrogen is univalent. Univalent nitrogen containing 6 electrons in its outermost shell, and that too if this nitrogen is neutral. So neutral univalent nitrogen containing 6 electrons in its outermost shell is known as nitrene, and this RCO group is known as acyl. So we can simply say acyl nitrene is formed. We can call this as an intermediate 2. This is intermediate 2. But this acyl nitrene is not that stable. That's why what happens over here is it forms a double bond over here, and this R will simply migrate to nitrogen. That means shift takes place over here. Here, shift will take place. Have a look. A shift will take place and R will be bonded now to nitrogen. So R will be bonded now to nitrogen. Then nitrogen forms a double bond with carbon, and carbon forms a double bond with oxygen. This is known as alkyl isocyanate. This is another intermediate of this reaction. So this is intermediate number 3. So this is intermediate 3. This was intermediate 2. But sometimes we simply say that this Br is lost. I mean, say it leaves as a leaving group. When it leaves as a leaving group, now it can be Ar as well. So here it can be Ar as well. So once this Br leaves, this R or Ar, either R with electron or Ar, will migrate to this place and it will form like this. That means it can be formed in one step directly as well. Indirectly as well it can be formed. So it can be formed directly or it can form via acyl nitrene. So this will be the product. This will be another, I mean say, intermediate. After this, this intermediate, I mean say alkyl isocyanate, after that I will directly write down that it reacts with other 2 moles of NaOH, and it will result in the formation of, have a look. You just broke this bond and add H over here and add ONA over here. Basically OH will be added, but OH will lose H positive and Na positive will be there. Okay. Similarly, break another bond, that means add another H and another 1 more ONA over here. That means it becomes Na2CO3 and this becomes primary amine. So in nutshell, we will get a primary amine over here plus Na2CO3 will be formed. Now, I hope this is clear to each and every one. So this can be one of the intermediates, this can be another intermediate, and this can be another intermediate. So this is what we call the mechanism of the reaction. But without mechanism, what we have to do is remove this C double bond O, and instead of that write down remaining part, that means amine. Yani, if I write a reaction like this, will you tell me what will be the product? What will be the product if I write down CH3 C double bond O NH2? This is known as acetamide. Acetamide is this. Now, upon treatment with, either I will write down Br2 plus, I mean say 4 times NaOH, or I will write down Br2 plus 4 times KOH, or I will write down directly like NaOBr, sodium hypobromite, or I will write down potassium hypobromite. What we have to do is, we have to simply remove this C double bond O and forms product like RNH2, that means methylamine, that means a primary amine. Now you know what will be the other side products, as I have shown that already over here, what are the side products. So no need to write down side products over here once again. Similarly, if I write this one, this is benzamide. This is benzamide. Now, this benzamide, upon treatment with similar reagents, what will be the product? Remove C double bond O. When you remove C double bond O, an aniline, that means aromatic primary amine, will be formed. And aromatic amine will be formed. Aromatic primary amine will be formed here. Aliphatic primary amine will be formed. Let me know in the chats. Let me know in the chats. Is Hoffman bromamide reaction clear to each and every one? Is Hoffman bromamide reaction clear to each and every one? Is this clear to each and every one? Let me know in the chats quickly. Let me know in the chats quickly, my dear lovely students. Let me know in the chats quickly. This is very important reaction. Hoffman bromamide reaction is very important. Now, have a look. There is some PYQs over here. Which of the following reactions is appropriate for converting acetamide to methanamine. Have a look. Have a look. This is acetamide, this is methanamine. This is a primary amine known as methanamine. Now tell me, which is the appropriate amine say among these? Is this Hofmann's bromamide reaction? Answer is yes. If this is Hofmann's bromamide reaction, it can never be a Stephen's reduction, it can never be Gabriel thalamide reaction, it can never be carbylamine reaction. So this is simply Hofmann's bromamide reaction, because we have converted amide to amine with one carbon lesser than the parent amide. After that, it's another question. I mean, say asked question is like this: intermediates formed during reaction of amide with Br2 and KOH. Which type of reaction is this? Hofmann bromamide. Now, in Hofmann bromamide reaction, I have already written over here what are the intermediates. It can be RCONHBr or ARCONHBr. That means N-bromamide ion, N-bromamide, I mean say can be the intermediate. After that, alkyl isocyanate can be the product, intermediate, and another is acyl nitrene. Have a look. Have a look. Here, it is not, this can be, I mean say intermediate, but this is not the intermediate. This is the intermediate, and this is also the intermediate, alkyl isocyanate. That means this will be the answer. RCONHBr. No, sorry, this is not the, yeah, this is RCONHBr, RCONHBr. Yes, N-bromamide is the, I mean say intermediate one, and this is alkyl isocyanate. That means this is another intermediate. So this is the right, others are not right. So here, this will be our answer. So this is the answer of the question. But here I want to say something extra, that is, this intermediate, if I put the value of R, N, double bond C, double bond O, this is known as alkyl isocyanate. If I put value of R, if R is CH3, if R is CH3, then can I say it becomes CH3, then N, double bond C, double bond O. This is known as methyl isocyanate. And remember, this was responsible for Bhopal gas tragedy. This was responsible for Bhopal gas tragedy. So this gas, methyl isocyanate, was responsible for Bhopal gas tragedy, which happened in 1984 most probably. Now, after that, this is extra information to you. So remember this, because this was asked in some competitive exams sometimes. I mean, say, I don't know the year exactly. Now, after that, it's Gabriel thalamide reaction. Thalamide. What is thalamide? Thalamide is this one. This is thalamide. This is imide. It's not amide. This is imide. So, can I write this H like this? When this is treated with a base, say for example, alcoholic potassium hydroxide, what will happen? This base will abstract this H. So this is negative, this is positive. Base will abstract this H. After that, it will result in the formation of this one. C double bond O, then C double bond O, then it is N having a negative charge on this, because H has been lost as H positive. Now this K positive will attract. So this is potassium. This is potassium thalamide. This is potassium thalamide. Now, what about this? What about this? This was thalamide. This is potassium thalamide. After that, we will treat this with RX. Now, remember, this step is an SN2 step. This is an SN2 step. So, we have to remember few points. R is not equal to tertiary over here. That means a tertiary alkyl halide cannot show the reaction. And number second, R can never be, I mean say here, an aryl group. For example, it can never be, I mean to say, aryl halide. So Rx can never be aryl halide. So it can never be aryl halide. So R can be any alkyl, generally 1 degree alkyl. It can be any alkyl, generally 1 degree alkyl, or it can be benzyl, say for example PHCH2. Okay, now What will happen over here? It will be simply this one. That means it will result in the formation of N, and here it will be R, after that double bond O. If we take primary alkyl halide, then this is alkyl, what we call phthalimide. Otherwise, it can be other values like benzyl as well there. Now, after that, once this is formed, have a look. Once this is formed, what will happen now? What will happen now? It can undergo hydrolysis. Say for example in acidic medium, then what will be the trick? Trick is simple. Break this bond, add H over here, OH over here. Break this bond, add H over here, OH over here. So the product of this reaction will be simply, this is benzene, then this becomes COH. Similarly, this becomes COH. So this is known as phthalic acid. This is known as phthalic acid. Plus, we will get primary amine. We will get primary amine. So we will get a primary amine over here. Similarly, if you take same reaction, I mean say, but in basic, I mean to say, or you can write down NaOH aqueous. If you are doing hydrolysis in basic medium, that means basic hydrolysis, what will it form? It will form primary amine. But when it forms an acid, base will convert that acid into salt. That means it will result in the formation of a sodium salt of, I mean to say, this carboxylic acid. Because this OH will abstract H from acid here, H from here, I mean say, both these H, both acidic hydrogens will be removed, and then it will become CO minus, and then Na positive will go there. So primary amine is formed. So this step is known as hydrolysis. This is known as hydrolysis, and this whole reaction during which phthalimide is converted to primary amine is known as Gabriel-phthalimide reaction. But remember, if instead of hydrolysis, this breakdown of, I mean to say, this compound takes place with the help of hydrazine. If it takes place with the help of hydrazine, then what will happen? Have a look. Reaction at that time will be known as hydrazinolysis. So instead of water breakdown, we can break down this with the help of hydrazine. So instead of hydrolysis, we can do this step with the help of hydrazinolysis. What will happen? Hydrogen, break this bond, hydrogen from this nitrogen goes to this, that means it remains as NH. Another hydrogen from this another nitrogen will go once again to hydrogen. That means one hydrogen from this nitrogen goes to nitrogen, and one hydrogen from this nitrogen goes to this nitrogen. That means once again a primary amine will be obtained. Primary amine will be obtained. After that, this C double bond O forms bond with this NH. So this is C double bond O NH. Then NH is single bonded to NH, and that NH will form bond to this. That means we will get like this. Here it is C double bond O, then it will form bond with NH, but NH is already attached to NH, then it will form bond with this. This is known as thalhydrazide. Thalhydrazide. And remember, this is very, very important point. Hydrazinolysis is more convenient and more preferable as compared to hydrolysis, whether it is acidic or basic. That means you have to remember this as well as this. But if question will be asked which one is more preferable, then it is hydrazinolysis. Otherwise you have to do hydrolysis. Now, another preparation is reductive amination of aldehydes and ketones. Have a look. Can I say this can be an aldehyde or a ketone? So this can be an aldehyde or a ketone. When it is treated with ammonia, it simply loses water molecule. When it loses water molecule, it results in the formation of imine. So this is known as imine. This imine, upon reduction by using a reducing agent, say for example hydrogen in presence of ranitidine, or we can use sodium borohydride, or we can use sodium cyanoborohydride. Sodium borohydride or sodium cyanoborohydride. What we have to do is break one bond, add hydrogen and hydrogen to this. That means that clearly understands that's clearly understood that it will result in the formation of a primary amine. So whenever you react ammonia with aldehyde or ketone, it first results in the formation of imine, which upon reduction results in the formation of primary amine. So first amination takes place and then after reduction takes place. So this is known as reductive amination. Similarly, if you write down like this is primary amine. Once again, this primary amine will simply lose water molecule. When it loses water molecule, then it will result in the formation of substituted imine. What is this? Substituted imine is known as Schiff's base, or sometimes we call this as anyl. So, but Schiff's base is much more common name. So, sometimes we call this as anyl. Similarly, this upon reduction yields what we call a secondary amine, because it results in the formation of CH and then NH and then R. So this NH is a functional group of secondary amine and this NH2 is functional group of primary amine. So whatever will be the value of this, you don't have to do anything with this part. You have to only remove this oxygen with hydrogen and you have to add either NH or NR to this. That means amination first, after that reduction by adding say hydrogen across this carbon double bond nitrogen, and you will get amine, whether primary or secondary. Now let me know in the chats, is this clear till now? Let me know in the chats, is this clear till now? So this was all about methods of preparation of amines. Let me know in the chats, is this clear till now? Is this clear till now? Okay, great. So this was all about methods of preparation of amines. Now we are having chemical reactions of amines. First of all, basic character of amine. So as we know, amines can act as a base. When amines are treated with acids, when base reacts with acid, they will form salt. For example, if we are having an amine, whether aliphatic or aromatic, whenever you react that with an acid, say for example HCl, HBr, HI, HNO3, H2SO4, any mineral acid or inorganic acid or halogen acids, then what will happen? Acid will lose H positive and base will abstract that H positive. So it will result in the formation of simply like this, Ar, either aromatic or aliphatic, then it will form NH3 positive and X negative. I hope this is clear. So formation of salt indicates that if acid is treated with amine, formation of salt means amine will act as base. That means it will donate its lone pair or it will abstract hydrogen or acidic hydrogen from an acid and results in the formation of this. So this is a very simple reaction. Now after that, we are having reaction with electrophiles. That means reaction of amine with electrophile. That means amine will act as a nucleophile and it will react with electrophile. So among that, first reaction is alkylation. Have a look. First reaction is alkylation. If we treat aromatic or aliphatic amine with alkyl halide, to differentiate this R and this R, I will put a bar over here. So this is R prime. What will be, say the product over here? First of all, have a look so that you will understand. Now this lone pair, this lone pair will attack this and X minus will be lost. By doing that, nitrogen will acquire a positive charge, X minus will come and that will abstract this H. That means H from amine and X from alkyl halide will be lost. So simple trick for this reaction will be like this. It is NHH and then it is X and R prime. So what will happen? H and X, remove H and X. So the product will be like this. It will be either aromatic or aliphatic part of this, then it will be NH and like this. So now tell me, this was primary amine. Primary amine on treatment with alkyl halide gives secondary amine. Now, so what you have to remember is amine gives H positive and alkyl halide gives X negative. So if alkyl halide is taken in excess, once again, aromatic or aliphatic part is this, then after that it is like this, secondary amine. I can write down in this fashion because we know that amine has to give H positive. So I will write down alkyl halide once again like this. What will happen? This H will be lost with this X and we will get AR or R here. After that it will be N, then it will be R prime, then it will be R prime. So this is a tertiary nitrogen. So this is tertiary amine which is formed. Here HX will be lost. Here HX will be lost. Are you getting me? Now after that, when this tertiary amine reacts with excess of alkyl halide, now this tertiary amine does not have any hydrogen. Now how will it react now? It will simply act as a nucleophile. Nucleophilic attack will take place and X minus will be lost. So we will get AR, R, then it is N, then it is R prime, then it is R prime, then once again it is R prime, then N is having positive charge and X minus will attract with that. That means a quaternary ammonium salt will be formed. So can I say if alkyl halide is taken in excess, then we will get quaternary ammonium salt via formation of secondary and tertiary amine from what we call primary amine on treatment with alkyl halide, but if alkyl halide is taken in excess. So what we have to do, we have simply removed these hydrogens and we have added what we call alkyl groups. So can I say this is known as exhaustive alkylation if it takes place at high temperature. So this is exhaustive alkylation. Now depending upon the value of alkyl group in alkyl halide, we can call it as exhaustive methylation, exhaustive ethylation, so on and so forth. So this is the reaction, what we call alkylation of amine. What is meant by alkylation of amine? You have to remove or you have to replace hydrogen of amine by means of alkyl group. Now let me know in the chats, is this clear? Let me know in the chats, is this clear? Let me know in the chats, is this clear? We will touch each and everything in this amine. So be with me so that each and everything will be revised. Now, let me know in the chats. Is this clear? Okay. Okay. Thank you. Thank you. Thank you. Thank you. After this alkylation, we are having acylation. But before that, in this nucleophile was amine and electrophile was alkyl halide. Okay. After that, acylation. What is meant by acylation? Acylation means introduction of acyl group. I mean to say, if you are having an aliphatic amine or an aromatic amine, suppose like this, what you have to do is, you have to simply remove this hydrogen and instead of this hydrogen, you have to replace this hydrogen by acyl group. Now, what are those acylating agents with the help of which we can replace hydrogen by acyl group? Have a look. This is known as acyl. This is known as acyl. So we will simply treat nucleophile, that means amine, either aliphatic or aromatic, with acid chloride or acyl chloride. What will happen? This nitrogen will basically attack C and Cl will be lost. After that, Cl minus will abstract hydrogen, that means HCl will be lost. In nutshell, trick is this: instead of hydrogen, put acyl group there. So what will be the product? ARR NHCOR. Or can I write like this? R C double bond O. I mean, say this first. After that, it is NH and R. After that, it is NH and R. Yeah, NH and AR. So this is amide. Amide has been formed. But how? When this amine, we replace this hydrogen of amine by acyl group. So this is acylation, but at the very same time, HCl will be formed. But remember, we have to take a base, a strong base like pyridine in this reaction, because this base will simply remove this acid, otherwise reaction will come backwards. So this base will remove this HCl so that reaction is favored in forward direction. Okay, now this is one thing. Another thing is that this amine can undergo acylation reaction if we treat this with, let us suppose this is R prime, okay, this with an anhydride. So acylating agent can be acyl chloride or anhydride. Reaction takes place generally in presence of base. Now what will happen? This lone pair will attack this carbon, or this will attack this carbon. That means it will attack an electrophile. After that, leaving group will leave, so it will leave like this. Suppose it will attack this carbon and this will be left. Now RCO minus will leave and it will abstract H, so it becomes RCOH, and this becomes once again an amide and substituted amide. So this is R prime C double bond O. Suppose this one, it forms bond with this nitrogen. That means it is NHR or it is NHAR. Then it results in the formation of RCOOH. I hope this is clear. Now remember, if you are having acyl chloride or acid chloride, remember, if R is CH3, then what will be the formula of this? Its formula becomes CH3COCl. This is known as acetyl chloride and this part is known as acetyl, and it is denoted by or abbreviated by AC. Similarly, if R is equal to C6H5, then it whole group RCOCl becomes C6H5COCl. This part is known as benzoyl. That means whole will be benzoyl chloride, this will be acetyl chloride. Have a look. If by introducing this COR, reaction is known as acylation, then by introducing this COCH3, that means acetyl, will be acetylation, and introduction of this benzoyl group will be benzoylation. That means this acylation can be, or this acylation can be either acetylation or benzoylation. For example, if you are having like this, if you are having an alcohol, if you are having an amine, say for example this amine, an aromatic amine known as aniline, and if you are reacting this with benzoyl chloride, in presence of, say for example, base, let us suppose NaOH. Now what will happen? This H and Cl will be lost. Basically this OH will abstract H, it becomes negatively charged, it will attack this and Cl will be lost, then Na and Cl will be formed. Or we can simply say HCl will be lost, and in basic medium, base and acid will form what we call NaCl plus water. So it will result in the formation of like this. So can I say this reaction is basically, we have replaced H by benzoyl group, hence this reaction is benzoylation reaction. This is known as benzoylation reaction, but this is benzoylation of this aniline. But what this aniline has done, it has lost H positive. Any species which loses H positive, can I say that is known as an acid? So in this reaction, this aniline acts as an acid. So I will write down over here, benzoylation of any acidic hydrogen containing compound, any acidic hydrogen containing compound, whether it's alcohol, whether it is phenol, or whether it is primary amine. So benzoylation of any acidic hydrogen containing compound by using benzoyl chloride, I mean say by using benzoyl chloride, I mean say C6H5 H5, C double bond O and Cl. This is benzoyl chloride. In presence of aqueous NaOH in general, or in presence of a strong base, is called, such reaction is called Schotten-Baumann or Schotten-Baumann reaction. So this is known as Schotten-Baumann reaction. So can I say this is one of the examples of Schotten-Baumann reaction? But it's not necessary that we will do, I mean say acylation, that benzylation. We can do acetylation as well. But this is what we call benzylation. This is what we call benzylation. Give me a second. This is benzylation of acidic hydrogen containing compound aniline. That's why this reaction is known as Schotten-Baumann reaction or Schotten-Baumann reaction. Now, here we are having, I mean to say, a few questions over here, or one question is most probably here. Now have a look. We are having this reaction. The following reaction, aniline with benzoyl chloride in presence of NaOH, resulting in the formation of this. Have a look. It's the same reaction. It's the same reaction. Phenyl, NHCO and phenyl. That means this is benzamide, but this is N-phenyl benzamide. Have a look. This is the same reaction. Now what is this reaction known as? I have already written over here. So this is Schotten-Baumann reaction. This is basically an asked question. So have a look how simple questions were asked. Now this is Schotten-Baumann reaction. After that, we are having reaction of amine with aldehyde and ketone. That means amine here will act as a nucleophile and aldehyde or ketone will act as an electrophile. Have a look. Have a look. If you are having an aldehyde or a ketone, it can be any aldehyde or any ketone, when it reacts with primary amine, when it reacts with a primary amine, what will happen? What will happen? It will simply lose water molecule. It will simply lose, remember, water molecule. When it loses water molecule, it will result in the formation of alkylated or substituted imine known as Schiff's base. Alkylated or substituted imine known as Schiff's base, sometimes also known as anyl, ANIL, or azomethine. Now, this upon reduction by using ranitol or sodium borohydride or sodium cyanoborohydride. You can write down sodium borohydride or sodium cyanoborohydride. What we have to do? We have already studied this reaction. Add hydrogen and hydrogen over here by removing one pi bond. So what will be the product? Product will be CH, NH and R. So can I say this is a secondary amine? So whenever primary amine reacts, remember, whenever primary amine reacts with aldehyde or ketone, it first results in the formation of a Schiff's base, which upon reduction yields secondary amine. Now, let me know what will be the product of this reaction. What will be the product of this reaction? Let me know in the chats. What will be the product of this reaction? Let me know in the chats. If you are having an aliphatic, I mean say aldehyde reacts with this, then what will be the product? I mean say we will not simply, whatever will be formed over here, that means a Schiff's base, we will not reduce that to secondary amine. Now tell me which type of Schiff's base will be formed over here, or what will be the product if aliphatic ketone is there reacting with, I mean say, let me remove this R and I will write down, I mean to say CH3 here, 1, and then I will write down this NH2 and then CH3 over here. What will be the Schiff's base over here? Very simple. Remove this and form like this. CH3, it will be CH, then it will be NCH3. So this will be the Schiff's base. Similarly here, Schiff's base will be like this. Double bond N, single bond CH3. Am I clear till now? Am I clear till now? This is shift space. But if you reduce this shift space further, it will result in the formation of CH3CH2, NHCH3, CH3CH3, NHCH3. That means a secondary amine. After that, if I remove this with the help of, if I write down a reaction like this, what will be the product? What will be the product over here? What will be the product over here? An aldehyde with aromatic primary amine. What will be the product? And another, if I treat benzaldehyde with an aromatic primary amine, what will be the product? Without reduction, what will be the product? Without reduction, what will be the product? It will be very simple. Loss of water will take place. So water will be removed. So what will be the product over here? It will be simply double bond N and then this phenyl ring. That means imine will be formed, but substituted imine, that means shift space. What will be the product over here? It will be this, then CH double bond N and then benzene. Phenyl ring. This is known as benzyl aniline or benzylidene aniline. Benzyl aniline or benzylidene aniline. So this is the reaction of primary amine with, whether it is aliphatic or aromatic, with carbonyl compound like aldehyde and ketone. So whenever primary aliphatic or aromatic amine reacts with aldehyde or ketone, Schiff's base will be obtained. Remember that forever. Schiff's base will be obtained. Not amine. Not this. Not this. Not this. But not this. Schiff's base will be formed. This will be formed only upon reduction. Otherwise, Schiff's base will be formed. Okay. After that, remember, if we have an aldehyde or a ketone and we want to react this aldehyde or ketone with secondary amine. Have a look. Whenever secondary amine reacts with an aldehyde or a ketone, so here R prime is either H, that means it is an aldehyde, or R prime is any alkyl or what we call aryl group. Any alkyl or aryl group. At that time, it is what we call a ketone. Now, whenever secondary amine reacts with aldehyde or a ketone, our aldehyde or a ketone must contain at least one alpha hydrogen. Why is it so? Have a look. So first of all, what will happen? This lone pair will attack this and it becomes here single bond O minus. Nitrogen will acquire a positive charge. After that, this O minus will abstract that hydrogen. So it will result in the formation of RCHH. Can I write down CH2 in the form of CHH? Then it is C single bond OH. Because it becomes O minus, it will abstract this H. Then it is R. Then here it is N. Then R2 with double prime. So it will be attacked over here. It becomes C single bond O and this H will go there. Now, this is generally an unstable carbonyl amine. Now, once it is formed, it undergoes dehydration. That means from this alpha hydrogen and this OH will be lost. I mean to say it will result in the formation of this product. Now have a look. This is the nitrogen attached to carbons on three sides. That means this is tertiary amine. That means amine. And this is double bond, carbon means ene. So this is known as enamine. So whenever primary amine reacts with aldehyde and ketone, we get Schiff's base. But if secondary amine reacts with aldehyde and a ketone, aldehyde or ketone must contain at least one alpha hydrogen, and after that it will result in the formation of enamine. This enamine can be further reduced by using H2 ranitol or what we call we can use sodium borohydride as reducing agent or sodium cyanoborohydride. Then this pi bond will be broken. It becomes CH2, it becomes CH. I mean to say at that time we will get tertiary amine. Okay, I mean to say if we do like this reduction of this, After reduction, it will give tertiary amine. Otherwise, it will give, without reduction, it will give enamine. Now, or sodium cyanoborohydride. What will be the product? It will be RCH single bond C. Now, give H to this after breaking this bond and give H to this. Then it is CH, R and then NR2 with double prime. Then this is what we call, known as tertiary amine. So we don't get tertiary amine till we reduce it. Otherwise we get enamine. Now after this, have a look. There is a question. When aniline reacts with benzaldehyde, condensation takes place and benzyl derivative is formed. This is known as, have a look. When benzaldehyde and aniline reacts together, they undergo benzyl derivative, and this reaction or this benzyl derivative is called, what is this known as? This is known as Schiff's base. So Schiff's reagent, no, this is Schiff's base. Schiff's base is formed. So whenever primary amine reacts with aldehyde or a ketone, Schiff's base is formed. And whenever secondary amine reacts with aldehyde or a ketone, that aldehyde or ketone must contain at least one alpha hydrogen, and it will result in the formation of enamine. Remember this. After that, we are having reaction with chloroform. Very, very, very important reaction. Whenever you are having primary amine, whether it is aromatic or it is aliphatic. Which type of amine? Primary amine. Whether aliphatic or aromatic. Whenever it reacts with chloroform and in presence of alcoholic potassium hydroxide, which acts as a base, so I will write down thrice so that reaction will be balanced. It always results in the formation of an isocyanide. It will result in the formation of an isocyanide or isonitrile or carbyl amine. But remember, this isocyanide, isonitrile or carbyl amine formation, when takes place, this is having basically an unpleasant odor, or we can simply say foul smell or foul odor, or we simply write down bad smell or bad odor. So its odor is, unpleasant, and with the help of, these two, we will get 3 times KCl as well as 3 times water. But important is this one. So primary amine, whether aliphatic or aromatic, they result in the formation of carbyl amine with bad smell. That means if we want to simply distinguish primary amine, secondary amine and tertiary amine, or we want to distinguish primary amine from rest of the amines. Suppose in this test tube we don't know whether it is primary amine, secondary amine or tertiary amine. If we perform this reaction, that means if we add to this amine, if we add chloroform and KOH, if bad smell or bad odor or unpleasant odor is there, that means this has been formed. If this has been formed, our starting material, that means our amine in test tube will be a primary amine. So this reaction can be used. This reaction can be used as a test for primary amines, or this can be used as a distinguishing test between primary amines and rest of the amines. So this test is shown only and only by, primary amine under the name, and this test is named as under the name carbyl amine test or isocyanide test or isonitrile test. So remember, only primary amines can show this test, not secondary amines, not tertiary amines. And NH2 of primary amine has to change into NC group. Now, after this, we are having a mechanism over here. Have a look. This is very important reaction. That's why you must know at least mechanism once. Now, what happened over here is we are having chloroform and base. Whenever you are having chloroform and base, You have already seen mechanism of Reimer-Tiemann reaction. So whenever we are having chloroform and base, base will abstract this acidic hydrogen and it will result, say for example, this is K positive OH negative, and it will result in the loss of water first, and then it will form CCl, Cl, Cl having a negative charge. That means a carbanion which is stabilized due to inductive effect, electron withdrawing effect of chlorine, as well as it's stabilized due to back bonding because chlorine is having vacant 3d orbital. So this is very stable carbanion, but after this it will simply lose. This Cl will be lost as Cl minus and K positive will be there. That means KCl will be lost and it will result in the formation of CCl2. This is simply dichlorocarbene, and this is basically deficient of electrons, so it can act as an electrophile. Now after that we are having RNH2, primary amine, or we are having aromatic primary amine. Now what will happen? This aliphatic primary amine or aromatic primary amine will donate its lone pair. This is having complete octet, this is not having complete octet, so it will accept electron, it will donate electron, so it will act as a nucleophile, it will act as an electrophile. What will happen? It will result in the formation of NHH, then it will form a bond with C, Cl and Cl. This CCl2 was neutral. When it accepts electron, it becomes negatively charged, and it was neutral. When it donates electron, it becomes positively charged. After that, have a look. Now, what will happen over here? This Cl minus will be lost, as it's a good living group. Cl minus will be lost. After that, it will result in the formation of this one, Ar, R, NH, H, then C. After that, when it will be lost, at the very same time here, I will show this one, KOH. OH minus will abstract this hydrogen as well, and it will simply result in the formation of this N. So I will remove this hydrogen. Or after that, this will simply abstract hydrogen. Let me show like this. Let me show like this. Have a look. Have a look. Let me show like this. First of all, let me show like this. This is negatively charged species. This negative charge will abstract this H, and it will simply stabilize negative and positive both. So it will result in the formation of Ar, and then R, then it is NH with lone pair, and this becomes CH, Cl and Cl. Now after this, this lone pair will form a double bond, and Cl is a good living group, so Cl minus will be lost. And it will result in the formation of ARR, then it will result in the formation of NH with a positive charge, double bond CH, single bond Cl. Is this clear to each and every one? After that, KOH will come. It's K positive OH minus. OH minus will abstract this hydrogen, so water will be lost, and K positive here will be lost. But this K positive and Cl will react and form another KCl. So it will result in the formation of AR, R, then N, then double bond C, then CH and Cl over here. After this, once again, it will form another bond and Cl will be lost. That means Cl minus will be once again lost, and it will result in the formation of AR, RR, then N triple bond C, single bond H. This is having a positive charge. After this, once again, KOH will come, a base will come, base will abstract this hydrogen, and it will lose simply a water molecule over here, plus K positive will be lost over here. But K positive and Cl will form another KCl, and it will result in the formation of AR, N, and then it will result in the formation of this one. So this is isocyanide. Once you have to see this mechanism, after that, leave this mechanism, but remember dichlorocarbene will act as an electrophile. Now remember this one simply, that remove NH2 from primary amine and form it NC when it is treated with chloroform and base. I hope this is clear to everyone, and this can be used as a test for what we call primary amines. Now, which of the following amine will give carbylamine test? Which of the following amine will give carbylamine test? Obviously, primary amine. Now, you have to check. This is NH, functional group, secondary amine. This is N, this is tertiary amine. NH, secondary amine. NH2 is the primary amine. That's it. Whether it is aliphatic or aromatic or aliphatic, primary amine will show carbylamine test. After that, we have few miscellaneous reactions, other reactions as well. Say for example, we have first reaction, and that is reaction with nitrous acid. But before that, let me know in the chats, is this clear till now? Am I clear till now? Am I clear till now? Am I clear till now? Let me know in the chats quickly. Am I clear till now? Let me know in the chats quickly. I will do each and everything in this chapter. Come on, let me know in the chats. Am I clear till now? Am I clear till now? Yes, clear. Kanmani. Okay. Mubina. Clear, sir. Thank you. Others to respond quickly. Okay. Asiba. Clear, sir. Okay. What about others? Okay. Thank you. Now, this is reaction of amine with nitrous acid. Have a look. First of all, if we are having a primary amine but aromatic one, if we are having aromatic primary amine, whenever it is treated with sodium nitrite and say for example acid, let us suppose acid is HCl, not necessary HCl, but let us suppose HCl. Both these will form HNO2. Now, this nitrous acid is prepared within the reaction. During the reaction means in situ, and HCl is taken in excess and at a temperature of 0 to 5 degrees Celsius. What will happen? It will result in the formation of benzene diazonium. Let me form this one. Okay, I will show this once again. Let me form resonating structure of this aniline or aromatic primary amine. So first of all, I will show aromatic primary amine reacting with. Just a moment, is everything clear? Okay. Now, I will react this with sodium nitrite and acid, let us suppose HCl. Both will form nitrous acid within the reaction. Then what will happen? This nitrous acid and HCl will react with this at a temperature of 0 degree to 5 degrees Celsius, and it will result in the formation of benzene diazonium salt. Say for example, benzene diazonium chloride. I can write down benzene diazonium chloride in this fashion, or I can write down benzene diazonium chloride in this fashion. I can write down benzene diazonium chloride in this fashion as well. Now, have a look. Either I will form benzene diazonium chloride like this, or I will form benzene diazonium chloride like this. This pi bond will shift towards here, so it becomes like this. And at the very same time, water will be obtained. Remember, this benzene diazonium chloride is basically aromatic diazonium chloride. It is stable because of resonance, but up to 0 to 5 degrees Celsius. And this reaction, with the help of which aromatic primary amine form benzene diazonium salt on treating with this NaNO2 HCl, this is known as diazotization reaction. This reaction is known as diazotization reaction. So this is an important reaction known as diazotization reaction. Now, during diazotization reaction, this salt, the benzene diazonium salt, is stable up to 5 degrees Celsius. Suppose if temperature is increased, I mean if temperature is more than 5 degrees Celsius and it is treated with water, and if it is treated with water, then remove this nitrogen, that means remove nitrogen gas, then it will result in the formation of phenol. But nitrogen gas is not removed until and unless you warm this, I mean say benzene diazonium chloride, or temperature is greater than 5 degrees Celsius. Otherwise, there will be no nitrogen gas evolution. So, what what is this reaction known as? Diazotization reaction. So during diazotization, what will happen? Benzene diazonium chloride, benzene diazonium salt is obtained from aromatic primary amine when treated with NaNO2HCl or HNO2HCl at a temperature of 0 to 5 degrees Celsius. So this was about primary aromatic amine. It reacts in this fashion. But if you take an aliphatic primary amine, say for example this one, for example this one, for example this one, aliphatic primary amine. Whenever it's treated with nitrous acid, whenever it is treated with NaNO2 HCl or directly with HNO2, that means nitrous acid, at 0 to 5 degrees Celsius, remember, at this temperature, it will result in the formation of alkane diazonium salt. Alkane diazonium salt. But this alkane diazonium salt is very unstable even at this temperature. So it will simply, in presence of water, it will simply lose this nitrogen and it will result in the formation of alcohol. It will result in the formation of alcohol plus nitrogen. But remember, this alcohol intermediate is basically R positive. That means when nitrogen is removed, intermediate is R positive. R positive is a carbocation. So you have to first rearrange it if possible. Rearrange if possible. If rearrangement takes place and it increases, rearrangement increases the stability of carbocation, you have to first increase the stability of carbocation. For example, if you want to write down a reaction like this, CH3, CH2, CH2 and NH2, what will happen? Have a look. What will happen in this reaction? First of all, it will result in the formation of CH3, CH2, CH2, and then N triple bond N with a positive charge, Cl minus. That means it will result in the formation of propane diazonium salt. But this is unstable. This is unstable even at ice cold conditions, 0 to 5 degrees Celsius, it is unstable. But this was not unstable at this temperature. This was stable because of resonance of this benzene ring. Now, here what will happen? Water will come and it will, break. Once this breaks out, first of all, I will result in the formation of a carbocation first. So it will result in the formation of carbocation CH3, CH2, CH2 positive. But this is stable because of 2 alpha hydrogens. So what will I do? I will simply shift this hydrogen to this. That means I will shift H as H minus. With electron, I will shift this hydrogen to this and it will result in the formation of more stable carbocation. Have a look. So this is having 6 alpha hydrogens. It was having 2 alpha hydrogens. Now it's having 6 alpha hydrogens. That means it's more stable. Now after that, what will we do? We will simply attack. This water will attack as a nucleophile and it will result in the formation of an alcohol. It will result in the formation of an alcohol and here nitrogen gas is evolved. So can I say, this is the only amine which at this temperature can evolve nitrogen gas. Hence, this reaction can be used as a test for aliphatic primary amine. This can be used as a test for aliphatic primary amine. So, whenever you are having nitrogen, an amine in which amine is aliphatic or NH2 is attached to, remember, sp3 hybridized carbon. Whenever you are having an amine in which NH2 is attached to sp3 hybridized carbon, what we have to do is replace this NH2 by OH. But first of all, form a carbocation. After that, if that carbocation undergoes rearrangement, you have to rearrange that. First of all, you have to form carbocation over here, rearrange carbocation wherever carbocation becomes more stable and you have to add OH there. That's it. That's the reaction. And this reaction can be used as a test for aliphatic primary amine because this is the only amine which at this temperature or under ice cold condition can evolve nitrogen gas. So this was about 1 degree amine, how aromatic 1 degree amine reacts and how aliphatic 1 degree amine reacts. After that, whether it is, say secondary amine which is aliphatic, whether it is aliphatic secondary amine or whether it is aromatic secondary amine. Remember, when aliphatic or aromatic secondary amine reacts with nitrous acid, can I write nitrous acid directly? Because we know nitrous acid has been obtained basically from NaNO2 and H acid. So it will lose water molecule like this, and it will result, aromatic or aliphatic secondary amine will result in the formation of nitrosoamine. And these nitrosoamines are yellow oily compounds. So yellow oily compounds will be obtained. Now tell me, primary amine will react and they will form different products. Secondary amine react with nitrous acid and will form different product. So with the help of nitrous acid, we can distinguish whether the amine starting material was primary amine or secondary amine. But sometimes we can even distinguish whether it is a primary aliphatic amine or a primary aromatic amine. So after that, if amine is a tertiary amine, say for example, an aliphatic tertiary amine is there, when it reacts with nitrous acid, it can simply attack this hydrogen, abstract this hydrogen, so it can form like this, and to this positive ONO or NO2 minus will attract. This is known as nitrite salt, and this nitrite salt is water soluble, remember. So water soluble nitrite salt is formed when tertiary aliphatic amine reacts with nitrous acid. But you know, nitrous acid generally is formed during the reaction by reacting NaNO2 and acid. Now after that, if tertiary amine is this one, if we are having an aromatic tertiary amine like this, now on treatment with nitrous acid, it undergoes electrophilic substitution reaction at para position, so it loses water molecule, and this electrophile nitrosonium ion will be added to para position of this ring, and it will form para-nitrosoamine, and this is generally green in color. So with the help of nitrous acid, we can distinguish primary, secondary and tertiary amines, and even we can distinguish primary aliphatic and primary aromatic amine. We can distinguish secondary this tertiary aliphatic and tertiary aromatic amine, as they form different products. I hope this is clear to each and every one till now. I hope this is clear to each and every one till now. Now have a look. There is one more asked question. There is one more asked question, and question is, if secondary amine, this is secondary amine, is treated with NaNO2HCl, what does that mean? That means HNO2, nitrous acid. That means nitrous acid. Secondary amine on treatment with nitrous acid gives product. Have a look, have a look, have a look. Whether secondary amine is aliphatic or aromatic, it always forms nitrosoamine. That means instead of this secondary amine, instead of this H, you have to add NO. Have a look. This is our secondary amine. Remove this H and add NO to this. That means this phenyl, this N, this methyl will remain there, and instead of H, NO should be there. That means this is our product. This is one of the asked questions or previous year questions. Now, after that, another reaction is reaction with Grignard's reagent. Have a look. This is an amine. Suppose I am writing down over here primary amine, whether aliphatic or aromatic. When it is treated with Grignard's reagent, Grignard reagent is either alkyl magnesium halide or it can be aryl magnesium halide. Now have a look. It can be phenyl magnesium halide or aryl magnesium halide as well. Remember, this is Grignard reagent, this is also Grignard reagent. Grignard reagent generally reacts in dry ether. Now, This part is partial negative, this is partial positive. Similarly, this part is partial negative, this is partial positive. Now, in case of amine, we know amine can lose what we call H as H positive. So, this can act as an acid. So, whenever this Grignard reagent reacts with an acid, it behaves as this negative part will abstract H as proton. That means it behaves as an acid. So, it will react like this. Similarly, this part, negative part will react with, I mean to say, H positive. That means acid. So, here we will get alkane. Here we will get benzene. H is here. Now, after that, this part is attached to this. So, let me write down R prime over here. Now, then it is AR. After that, it is R. Then it is NH. To this NH, MgX is attached. Similarly, here it is AR or R. Then NH. Then MgX is attached to this. We know reaction of any acidic hydrogen containing compound with Grignard's reagent to form alkane in general is known as Zeri-Vechanoff's reaction. So, this is one of the examples of Zeri-Vechanoff's reaction. After that, its reaction with carbon disulfide. Now, have a look. Now, have a look. If you are having primary amine like this, and that too aliphatic, this is aliphatic primary amine, when it reacts with carbon disulfide, we simply warm this. What happened? What will happen over here? Have a look. Have a look. This lone pair will attack C. Have a look. Have a look. This lone pair will attack C, and this one of this bond will be broken. That means it becomes S minus. Nitrogen will acquire positive charge. S will acquire minus charge. This will lose H positive, and this will accept H positive. That means when it loses H positive, it becomes RNH. RNH. But it has formed a bond with this C. So, single bond C. This double bond S is intact. So, it is double bond S. But this single bond becomes S minus. But this S minus abstracts hydrogen from nitrogen. So, it becomes SH. So, first it will form this one. After that, it will react with HgCl2. It will react with HgCl2. Have a look. I will simply tell you the trick. Suppose this Cl will abstract this H and this H. That means it will result in the formation of twice HCl. After that, suppose this Hg reacts with S, that means it will result in the formation of HgS. Then here it will be the formation of this one, double bond, and then C, then double bond this one. This is known as alkyl isothiocyanate. And its smell is like that of mustard oil. So, it gives a mustard oil smell, and this reaction is known as Hoffman's mustard oil reaction. Hoffman's mustard oil reaction, and is used as a test for primary aliphatic amines. Only aliphatic, not aromatic. Primary aliphatic amines. That means if mustard oil smell is there, that means our starting material will be primary aliphatic amine. So, with the help of this, it can be used as a test for primary aliphatic amines. So, with the help of this, we can distinguish primary aliphatic amine from rest of the amines. Take. So, Hoffman's mustard oil reaction and is used as a test for primary aliphatic amines under the name Hoffman's mustard oil test. Hoffman's mustard oil test. I hope this is clear. So, this is important reaction because this is a test. So, you don't need to remember when this is aromatic what will happen. But let me tell you, if this is aromatic, if this is phenyl, then here it will be phenyl isothiocyanate. That means at that time it will be, say instead of R, it will be aryl group. But that reaction will be, taking place in different manner, but the product will be like, instead of this R, if it is AR, then in product it will be AR, but reaction will be something different. But you don't need to remember that reaction. After that, after this reaction, we have another reaction with phosgene. Phosgene means COCl. COCl2 means carbonyl chloride. I mean to say, if you are having a primary amine like this, it reacts with phosgene, COCl2. What you have to do is simple. You need 2 molecules or 2 moles of this primary amine. Remove this H and Cl, remove this H and Cl. That means you will simply result in the formation of this one, RNH, single bond, C double bond O, then single bond NHR. Remember, if this is NH2CO NH2, that is known as urea. This is known as N-dialkyl urea, that too a symmetrical dialkyl urea. So this is symmetrical N-dialkyl urea. So this is one of the reactions with primary amine. Similarly, if we are having secondary amine, then what will happen? Have a look. If we are having secondary amine, phosgene or carbonyl chloride reacts in similar manner. HCl will be lost. Here HCl will be lost. Now, what will be the product? This was dialkyl, your di-substituted urea. Now we will get symmetrical tetraalkyl urea or tetra-substituted urea. Tertiary amine cannot react with phosgene like this because tertiary amine does not have any acidic hydrogen. I hope this is clear to you. Now, after that, we are having oxidation. Remember, different amines in presence of different oxidizing reagents will give us different products. For example, if we are having an amine like this, CH3, CH2, NH2. What is this? This is a primary amine in which this functional group is attached to primary carbon. But once again, if I write down like this, once again, what is the functional group? NH2. Whenever NH2 is functional group, it is primary amine. But the difference is, here primary amine is attached to a secondary carbon. I mean, say nitrogen, NH2 is attached to a secondary carbon. Now, if I write down like this, this is once again a primary amine because NH2 is the functional group. So this is primary amine. But my dear students, here in this primary amine, functional group NH2 is attached to tertiary carbon. So this is the difference, that NH2 is attached to primary, NH2 is attached to secondary, NH2 is attached to tertiary. But as NH2 is the functional group, all these are primary amines. Remember. When this is oxidized by using KMnO4, that means a strong oxidizing agent, what you have to do? Remove one hydrogen from functional group, one hydrogen from alpha position. Here, one hydrogen from functional group, one hydrogen from alpha position. That means there will be a double bond between alpha carbon and functional group nitrogen. Like this. So, imine will be formed. C double bond NH, imine will be formed. Here, once again, an imine will be formed. C double bond NH, imine will be formed. Now, after that, once this imine is obtained, we hydrolyze this imine. That means hydrolysis of this imine will result in the formation of, break this bond, add 2 hydrogens over here, add 2 OH groups over here. But whenever 2 OH groups are attached to same carbon, generally they will lose water molecule and it will be converted to C double bond O. So we will get an aldehyde over here, and here we will get a ketone. Here we will get a ketone. So remember forever, if primary amine is such that nitrogen or NH2 group is attached to 1 degree carbon, we generally, by doing this reaction, we will get aldehyde. And if primary amine is such that NH2 is attached to secondary carbon, by doing this reaction, I mean, say first oxidation and then hydrolysis, we will get ketone. But whenever you are having a primary amine in which nitrogen is attached to tertiary carbon, upon oxidation by using KMnO4, amine will be converted to a nitro compound. It's a very simple, just you have to convert NH2 to NO2. So this was if primary amine is there and oxidizing agent is NH2, what will happen? After that, if you are having a secondary amine, have a look, and oxidizing agent is KMNO4, then we will get tetraalkyl hydrazine. Remember, oxidation product. And if the same secondary amine undergoes oxidation by using H2SO5. H2SO5 is known as Carrot's acid. Or by using H2O2 as an oxidizing agent, then we get hydroxylamine as the product. And remember, tertiary amines generally do not oxidize. They do not get oxidized by using KMNO4. That's why we either use Carrot's acid, or we use H2O2, or we use, ozone. Now, it results in the formation of amine N oxide. This is a coordinate bond between nitrogen and oxygen. After that, remember, if you are having an aromatic amine, say for example aniline, and it is oxidized by using K2Cr2O7 in acidic medium, it generally forms a black dye. Called aniline black. But if same reaction, that means if we treat this with K2Cr2O7, H2SO4, but under controlled conditions, or by using Na2Cr2O7H2SO4, that means sodium dichromate in presence of H2SO4, or H2CrO4, that means chromic acid, then remember, it results in the formation of para-benzoquinone. If this same aniline, say aromatic amine, is oxidized by using per acid, say for example trifluoro, say it's basically per-acetic acid if it is CH3. This is trifluoro per-acetic acid. Now, what will happen over here? It will result in the formation of nitrobenzene. And if this aniline is oxidized by using Carrot's acid, H2SO5 or H2O2, it generally results in the formation of nitrosobenzene as primary product. So, have a look. By using different oxidizing agent, different products can be obtained. So, this was all about oxidation. You have to remember this oxidation as well. After that, we are having electrophilic substitution reactions of aniline, aromatic amine. Very, very, very important. Have a look. Now, first of all, you must remember this one, that this NH2 group is very strong activating group. It's a very strong activating group. That means it will donate electron very strongly, activating group. And it will increase electron density of the ring at both ortho and this para position. That means it will increase electron density of all the ortho positions and para positions, because it donates strongly electrons. That's why this is a strong electron donating group or strong activating group, and it is ortho para directing group as well. Now, if it is treated with bromine water, that means bromine in presence of water, or bromine in presence of, say for example, inert solvent CS2, then here what will happen, as it increases electron density of the ring at every position, because it donates electron very strongly, that's why electrophile goes to this ortho position, as well as para position. That means here para ortho substitution will take place. That means here polyhalogenation or trihalogenation product will be obtained. Now the question is why trihalogenation takes place? Because this ring was very much activated for electrophiles. Why? This ring was very much activated because this is a strong activating group. It donates electrons strongly. Now, if we want that it should not donate electron that strongly, that means if we want to, decrease its activating character, then our ortho and para products can be obtained. How can we, decrease its donating power? That is by protection of amino group. That means by protection of amino group. How this protection is done, have a look. How this protection is done, have a look. Have a look. Now, you are having this this NH2 group. We will simply do acetylation of this. Suppose I will do acetylation, that means I will replace this H by acetyl group, and suppose acetylation is done by this acetic anhydride. Generally, this acetic anhydride came from acetic acid. Generally, we use sodium salt of that acid, sodium salt of acetic acid, sodium salt of that acid from which this anhydride has been obtained. Now, what will happen over here? Have a look. This H will be replaced by, this COCH3 group. That means we will simply do acetylation. So, in first step, what is the first step? It is acetylation. Now, have a look. By introducing this acetyl group, this nitrogen will take part in resonance here as well. That means this will withdraw electron towards itself due to resonance. Because of that, it will now not donate electrons strongly to benzene ring. That means it will donate electrons to benzene ring, but not that strongly. That means it will not activate this benzene ring as it was activating before this acetyl group. Hence, we will do now our reaction. What was our reaction? Our reaction was bromination or halogenation. Say, for example, here CH3COH will be lost, and in presence of, say, for example, CH3COH, what will happen? Now, bromination will take place. Br positive will go. It will go either to ortho position or to para position. But remember, here, as we know, repulsion is there. So this will be the minor product, and para 1 will be the major product. So para 1 will be the major product. Then this product will be the major product. After this, as ortho and para, as at ortho and para position, electrophile goes at either ortho or para. Now, what will we do? We will simply do hydrolysis of this. So, in protection, we will do total in 3 steps. First step is acetylation. Another is the reaction, which is, taking place at that time. And third one is hydrolysis. That means removal of this acetyl group. How will you remove acetyl group? Give OH to this acetyl from water and give H to this. Similarly, give H to this N and give OH to this. That means CH3COH will be lost, and we will get our desired product. That means we will give, here we will get, orthobromoaniline and parabromoaniline. But remember, para 1 is the major product. Para 1 is the major product. So this is the major product. So if you don't, if we don't do, acetylation or protection, then polyhalogenation will take place. But with the help of this acetylation, monohalogenation will take place at ortho and para position. I hope this is clear to each and every one. Is this clear till now? Let me know in the chats quickly. Let me know in the chats quickly. Is this clear till now? Because it hardly takes me now 30 to 40 minutes maximum to complete this chapter. Now, let me know in the chats. Is this clear? Is this clear till now? Am I clear till now? Am I clear till now? Kirthana, thank you. Mubina, thank you. Kanmani, thank you. Okay. So, now after that, we have another reaction, that is nitration. Have a look. This is very, very important reaction. So, for example, we are having aniline and we want to do its nitration, and we know nitration takes place in acidic medium. Say for example, nitrating mixture is there, HNO3 is there and H2SO4 is there. But remember, whenever nitrating mixture is there, this H2SO4 will act as an acid and its function is to generate electrophile from this HNO3. And in this reaction, nitric acid is not an acid. In this reaction, nitric acid will act as a base. In every nitration reaction, nitric acid will act as a base if H2SO4 is there. Now, after this, NO2 positive will be generated and NO2 positive should go to, it should go to ortho position. It should go to ortho position and it should go to para position. But what we will observe over here, that it will go to meta position as well. Now the question is, why is it so? NH2 was ortho para directing, then why it, then why electrophile goes to meta position? And that too, you have a look, this is formed only 2%, this is 51% and this is 47%. That means almost half is the meta product. Remember, NH2 group is ortho-para directing, but NH2 group in acidic medium is meta directing also. Why? Have a look. Because whenever we are having aniline in acidic medium, it will abstract H positive and will result in the formation of NH3 positive. This is known as anilinium ion. And remember, it is a meta directing group. Now, the question is, why this is less, why this is more, why this is in between them? Now, NH3 positive will simply withdraw electron with the help of inductive effect. So, it will decrease electron density of ortho more because it is closer to ortho. It will decrease electron density of para, but it will decrease that in lesser amounts as compared to meta and ortho. So, the most, that position which is having, that position to which this NH3 positive decreases electron density most is ortho 1. That means ortho is the most electron deficient position. That's why electrophile will not go there as much. That's why it's only 2%. But among meta and para, meta is electron deficient as compared to para due to NH3 positive. That is why electrophile prefers much para position. That's why it is 51 and it is 47%. I hope this is clear. So now tell me why this is formed. This is formed due to formation of anilinium ion. If anilinium ion is not formed, this cannot be produced. Now tell me, our aim was to produce ortho nitroaniline and para nitroaniline. So if we want to produce these two only, if we do not want to produce this, we don't have to form anilinium ion. But anilinium ion is not formed only if H positive is not there. But we have to conduct this reaction in acidic medium, so we cannot change acidic medium. Second thing is that this aniline should not give its electron to H positive. That means we have to decrease its electron donating nature, and we can decrease its electron donating nature by protection. So once again, protection of amino group takes place. Because by protecting this amino group, what will happen? Have a look. First, we will do acetylation. Acetylation generally takes place by using CH3, CO, CH3. I mean to say acetic anhydride in presence of sodium salt of this acetic acid. Now this H and this will be lost. So CH3COOH will be lost. Instead of H, COCH3 will be there. That means acetylation will be taking place over here. Due to this acetyl group, what will happen? It's an electron withdrawing group. It will decrease electron density of this nitrogen. When electron density of nitrogen is decreased, it's not able to donate its electron. It's not able to donate its electron to H positive now. So it will not donate its electrons to H positive now. If it will not donate electron to H positive now, there will be no anilinium ion formation. So what will happen? It will donate electron to ring and it will increase electron density of the ring at ortho and para position. That's why their electrophile, I mean say NO2 positive, will go either to ortho position or to para position. But remember, para will be the major one. Para will be the major one. So this will be formed. Para will be the major one. And finally, what will happen? Finally, we will do hydrolysis. By hydrolysis, what we will do? We will simply remove this acetyl group or this acetyl group and we will obtain our desired products. That means ortho nitroaniline and para-nitroaniline, but para-nitroaniline will be the major product. So this is major product. I hope this is clear till now. Let me know quickly, is this clear? Let me know quickly, is this clear? Let me know quickly, is this clear? Let me know in the chats, is this clear? Come on, dear students, let me know. Quickly, come on. Yes, sir. Okay, thank you. Now, after this, we are having another reaction, that is sulfonation. That means we have to introduce SO3H group. Now, have a look. Whenever aniline is treated with H2SO4, remember, this is sulfonation, but sulfonation is always a reversible process. So, whenever we are treating this aniline with concentrated sulfuric acid, or we want to do sulfonation of this aniline or aromatic amine, remember what happens over here. First of all, it will result in the formation of NH3 positive and HSO4 minus or OSO3H minus. So it will result in the formation of this. That means once again an anilinium ion is formed. When anilinium ion is formed, meta product can also be formed. Yes or no? But meta product can be formed, ortho product can be formed, para product can be formed, but our para product is more stable. Para product is more stable. If para product is more stable, para, ortho, meta, all are in equilibrium with each other because they are, this reaction is reversible. Now tell me, if I increase the temperature, if temperature is increased 453 to 473 Kelvin, now tell me, high temperature, we know at high temperature, which one is the most stable, product, it will be a para one. So that means ortho, meta will not be the major products. Whatever they will be formed, they will be converted to, para, because at high temperature, remember, this will be formed. At high temperature, there will be loss of water molecule, and after loss of water molecule, it will result in the formation of this one. Now the question is, can we say meta can be formed? Yes, meta can be formed, but very in small amounts. Ortho can be formed in small amounts. Why not meta is formed in bulkier amounts like, nitration? Because this reaction is reversible. As this reaction is reversible, meta will go to, that product which is more stable. Because have a look. This SO3 minus can accept H positive from here. So we will get simply SO3H at para position, and this is NH2 at this position. This is known as para-aminobenzene sulfonic acid, commonly known as sulfanilic acid, and this is the major product of this reaction, as this is thermodynamically stable. So this is the major product, and this is its Zwitter ion or dipolar ion. Actually, why this temperature is there? Okay, during this step, water is lost. Why this temperature is given? Because at high temperature, thermodynamically stable product will be formed, or other products will be converted to this thermodynamically stable product. That's why this is the major product of this reaction. After this, we are having distinction between primary, secondary and tertiary amines. We can distinguish primary, secondary and tertiary amines with the help of this method. Have a look how. Benzene sulfonyl chloride is known as actually Hinz-Burgess reagent. So this is Hinz-Burgess reagent. When it reacts with primary amine, what will happen? it will attack to this sulfur and Cl will be lost. That Cl minus will abstract H from this. That means first it will result in the formation of what? Have a look. It will result in the formation of this one. S double bond O, and then N, then H, and then R. Or I will write down like this. This is NR and this is H. This is known as N-alkyl benzene sulfonamide. At N, it's alkyl, so it's N-alkyl benzene sulfonamide. And this is a solid. Now, if this is treated with alkali or base, have a look. Say for example, KOH is there. Now what will happen? This OH minus will abstract this H and water will be lost and it will result in the formation of this. Double bond O, then it is NR having negative charge and K positive will attract. So can I say it reacts with alkali? That means this is basically soluble in alkali. So it is soluble in alkali. Now tell me, whose solid is soluble in alkali? Primary amines. It's solid of primary amine which is soluble in alkali when primary amine reacts with Hinz-Burgess reagent or benzene sulfonyl chloride. Similarly, if benzene sulfonyl chloride or Hinz-Burgess reagent reacts with secondary amine, once again it will attack over here, Cl minus will lose, Cl minus will accept that H. So it will result in the formation of NN dialkyl, benzene sulfonamide. Now, remember, as there is no acidic hydrogen now, here it was acidic hydrogen. So, if it is treated with alkali, there will be no reaction. That means it is insoluble. This solid is insoluble in alkali. So, whose solid is insoluble in alkali? Secondary amine when treated with Hinz-Burgess reagent. That means primary amine reacts in different manner, secondary amine reacts in different manner, and tertiary amine does not react with benzene sulfonyl chloride. That means it remain as it was. I mean say it remain in liquid form. So this is a tertiary amine. So there will be no reaction at all. So can we say with the help of this method, with the help of Hinz-Burgess method, we can distinguish primary, secondary and tertiary amines. So this is the test with the help of which we can distinguish primary, secondary and tertiary amines. One more thing you have to remember. It's written in your NCERT that nowadays toluene sulfonyl chloride replaces benzene sulfonyl chloride. That means nowadays we generally use toluene sulfonyl chloride instead of benzene sulfonyl chloride. That means we use this one. Nowadays we use this one. We use this one instead of this one, instead of benzene sulfonyl chloride. I hope this is clear. After that, it's a question, the amine that reacts with Hinz-Burgess reagent to give an alkali insoluble product. Have a look. Alkali insoluble product is given by secondary amine when treated with Hinz-Burgess reagent. So Which among these is the secondary amine? This is the secondary amine, hence this can be the product. This is primary amine, this is tertiary amine, this is primary amine, so this is the product. I mean, say this is the answer of this question. Now, second is, identify the compound that will react with Hinsberg's reagent to give a solid which dissolves in alkali. Whose solid dissolves in alkali when treated with Hinsberg's reagent? It's primary amine. So have a look. This is primary amine. This is nitro. No. This is tertiary amine. No. This is secondary amine. No. This is nitro group. No. So this is primary amine. After this, we have another method, that is Hoffman's method. Have a look. This is known as diethyl oxalate. So whenever diethyl oxalate reacts with primary amine, have a look. When it reacts with primary amine, it results in the formation of ethanol, 2 moles of ethanol, and it will form. So I will write down 2 moles of ethanol here, and it will form C double bond O, then NHR. C double bond O, then NHR. This is known as substituted oxamide. Substituted oxamide. And this is a crystalline solid. This is a crystalline solid. That means with diethyl oxalate, primary amine forms a crystalline solid. But if diethyl oxalate reacts with secondary amine, it will react like this. It will react like this. It will lose ethanol and it will form C double bond O NR2, C double bond O OET. This is known as oxamic ester. This is known as oxamic ester, and this is a liquid. That means primary amine reacts with diethyl oxalate in different manner, and secondary amine reacts with this in different manner, and tertiary amine do not react. Tertiary amine do not react. So with the help of products, we can simply say, that our starting material is either primary, secondary or tertiary. That's why this method, during which primary amine, secondary amine or tertiary amine can form different products with diethyl oxalate, is known as what we call Hoffman's method. So with the help of Hoffman's method, we can distinguish primary, secondary and tertiary amines as well. So this was all about amines. Now we are having last portion of this. Now it will take hardly 10 to 15 minutes. Now have a look. Now this is first reaction, that is diazotization reaction. I have already shown you this reaction. Have a look. Whenever you are having primary aromatic amine and it reacts with sodium nitrite in acid. Say for example, acid is HA. Now what is A? I will show you in a while. Now similarly, both reacts and form nitrous acid, and acid is there at a temperature of 0 to 5 degrees Celsius. What will happen? It will result in the formation of diazonium salt over here. Either a triple bond will be between this and this, or there will be a double bond between both nitrogens like this. Then this will be having a positive charge, this will be having negative, and twice water will be there. So this is stable up to 0 to 5 degrees Celsius, but if temperature is increased, it will result in the formation of phenol. And what is this HA? This HA can be either HCl or HNO3 or H2SO4 or HBF4. This is HCl, you know, this is hydrochloric acid, nitric acid, sulfuric acid, this is tetrafluoroboric acid. So if this A minus is Cl minus, this is known as benzene diazonium chloride. If it is NO3 minus, then it is known as benzene diazonium nitrate. If it is HSO4 minus, then this is known as benzene diazonium hydrogen sulfate. If it is BF4 minus, then it is known as benzene diazonium tetrafluoroborate. So this reaction is known as diazotization reaction. So this is all about its preparation. You have to remember only one preparation, that's it. So no need to go through mechanism. I can show you the mechanism, but it's not important for you. Remember in this fashion only. Now, after that, we are having few reactions in which, have a look, in which this nitrogen group will retain, and few reactions are in which this nitrogen group will be replaced by another monovalent group. Have a look, have a look. Now, first of all, we have replacement or displacement of nitrogen. First, we have to replace this by hydrogen. How will we replace this N2 by nitrogen? Have a look. We will replace this by either using H3PO2. H3PO2 is known as hypophosphoric acid or phosphenic acid. Hypophosphorus acid or phosphenic acid in presence of water. This is first reagent. Or you can use ethanol. But remember, what will happen? This N2 will be lost. N2 will be lost. Instead of that N2, there will be hydrogen. Now, what has happened to this? Hydrogen has been added, that means reduction. So this is an oxidizing, this is a what we call a reducing agent. But to this reducing agent, oxidation takes place. That means it becomes H3PO3. Itself, it's oxidized and it has reduced this, say benzene ring. Now, this benzene diazonium salt ring. Now, and after that, this ethanol is formed to ethanol. That means removal of hydrogen has been taken place. That means oxidation has been taken place to this and reduction to this. So remember reagent. With the help of this reagent, you can replace N2 by hydrogen. You have to remember this. After that, replacement by hydroxyl group. Very easy, very easy. If you want to replace this N2, okay, here N2 will be always lost. So nitrogen gas will be always formed because we have to replace N2. Now, if you want to replace this N2 by hydroxyl, you have to treat it with water and temperature should be greater than 5 degrees Celsius. That's it. That's it. So here it will be OH. So hydroxyl group replaces this N2. So N2 will be the, nitrogen gas which will be evolved. I hope this is clear. After that, replacement by halogens. Have a look, my dear students. Have a look. If you are having N2Cl, that means benzene diazonium chloride, what we have to do is, we will simply replace this. We will simply replace this. How? Have a look. We will replace this N2 with the help of with the help of, Cu2X2 in presence of HX or Cux in presence of HX. Here X is either chlorine or bromine. That means we will get chlorobenzene or bromobenzene over here. Chlorobenzene or bromobenzene over here, and this X is that X which is attached to this copper. That means here cuprous, Cu positive ion is basically acting as a catalyst and it will result in the formation of chlorobenzene or bromobenzene. This reaction is known as Sandmeyer's reaction. This is known as Sandmeyer's reaction. Similarly, if you use copper instead of copper powder instead of cuprous in presence of HX, X is once again Cl or Br. That means you will get chlorobenzene once again. But this, or bromobenzene once again. But this chlorobenzene or bromobenzene formation on treatment of benzene diazonium chloride with copper powder and HX is known as Gattermann's reaction or Gattermann's synthesis. So this is Gattermann's reaction. In both the reactions, chlorobenzene and bromobenzene will be obtained, but yield of chlorobenzene or bromobenzene is always more in Sandmeyer's reaction than Gattermann's reaction. This is very, very important point written in your NCERT. So remember this. So where yield is more, yield will be always more in, yield of chlorobenzene and bromobenzene will be always more in what we call Sandmeyer's reaction. That means if we want to prepare chlorobenzene or bromobenzene from benzene diazonium salt, we will say Sandmeyer's reaction is preferred over Guttermann's reaction. Similarly, if you treat it with Ki and warm, here nitrogen gas will be removed. Once again, nitrogen gas will be evolved, and instead of nitrogen, here iodine will be attached. That means here iodobenzene will be obtained. Here and here chlorobenzene and bromobenzene will be formed. That means nitrogen has been replaced by either chlorine or bromine or iodine. But if you treat this with HBF4, tetrafluoroboric acid, first of all, it will result in the formation of N2 BF4 minus. That means here anions are replaced. After that, if this is heated, it will lose nitrogen and it will result in the formation of fluorobenzene. That means this N2 is here replaced by fluorine. That reaction with the help of which N2 is replaced by fluorine is known as Bals-Schimmann reaction. So in Bals-Schimmann reaction, end product is fluorobenzene, and in Sandmeyer reaction or Guttermann reaction, end product is chlorobenzene or bromobenzene. I hope this is clear to you, but remember reagents as well. So this is replacement by halogens. After that, replacement by cyano group. That means if you treat benzene diazonium chloride to CuCN KCN, once again, here it is cuprous, Cu positive is there. That means it resembles like that of Sandmeyer reaction. That's why this is also known as Sandmeyer reaction. So benzonitrile will be there, and this N2 group is replaced by cyano. So replacement of N2 by cyano, this is also known as what we call Sandmeyer's reaction. After that, next is replacement by nitro group. Have a look. If you are having N2Cl minus, you first treat it with HBF4 so that anions will be replaced, and finally you treat it with NaNO2. Here this N2 will be lost, and instead of N2, NO2 will be there. So remember reagents, which group or which reagent will replace NO2 by which group. I hope this is clear. Then next is arsenic acid group. What is arsenic acid group? COOH is known as carboxylic acid group, SO3H is known as sulfonic acid group, ASO3H2 is known as arsenic acid group. Have a look. When you are having benzene diazonium chloride, and if we treat this with Na3ASO3, now first of all, it will replace NO2, this N2, it will replace N2, but Na positive and Cl minus will form NaCl. After that, it will result in the formation of ASO3NO2. After that, we will replace both these sodium by hydrogens. That means NaCl will be lost, and here it will result in the formation of ASO3H2. Finally, N2 is replaced by arsenic acid group, and this reaction, whole reaction, with the help of which N2 is replaced by, I mean to say that ASO3H2, that means arsenic acid group, is known as Barth reaction. So this is a named reaction known as Barth reaction. After that, remember, replacement by an aryl group. Have a look. If you are having benzene diazonium chloride like this, and you want to replace this N2 by aryl group, what you have to do is, you have to treat it with either benzene, that means aromatic compound, or you have to treat this diazonium chloride with substituted, I mean say benzene, say for example NO2. What we have to do is, we have to simply join this ring to this ring by removing N2. We have to join these two rings by removing N2. But this aromatic ring should couple with this benzene ring or this phenyl ring from para position, irrespective of electron donating or electron withdrawing group. Irrespective of electron donating or electron withdrawing group. So what will happen? Nitrogen gas will be evolved in both the cases. Nitrogen gas will be evolved. After that, it will result in the formation of here, like this. And here, it will result in the formation of this one. So have a look. This is basically attached at para position with respect to this group, whether it is electron donating or electron withdrawing group. And this reaction, with the help of which we simply replace this N2 by aryl group, this reaction is known as Gomberg-Bachmann reaction. This is known as Gomberg-Bachmann reaction. So this is once again a named reaction. Gomberg-Bachmann reaction. Another is those types of reactions in which nitrogen is retained. First is like this. First is reduction. Say for example, you are having N, double bond N with a positive charge and Cl minus. You are having this benzene diazonium chloride. Now if it is treated with SnCl2HCl, I mean say a reducing agent, or Na2SO3, then remember this bond will be broken and hydrogens will be added, and it will result in the formation of phenylhydrazine. It will result in the formation of phenylhydrazine. But you have to remember, if this benzene diazonium chloride is treated with a vigorous reducing agent, a strong reducing agent like zinc HCl, then first it will result in the formation of phenylhydrazine, but reaction will not stop over here. It will further react. It will further undergo reduction like this, and it will break this bond, and it will result in the formation of, here H will be added, so it will become NH2. This becomes NH3, but that NH3 will react with HCl and results in the formation of NH4Cl. So here nitrogen is retained, nitrogen is attached to this benzene ring. After that, we are having coupling reactions. Have a look, this is very, very, very important reaction. Whenever you are having a benzene diazonium chloride and it can react with phenol, it can react with phenol, I mean say it can couple with phenol as well as with aromatic amine, that means aniline. Aromatic amine, that means aniline. But remember forever, when it couples with phenol, it takes place in basic medium. That means reaction takes place at a pH of 9 to 10. That means we can simply say in basic medium. And here reaction takes place at a pH of 4 to 5. That means we can simply say in acidic medium. What will happen? Simply coupling takes place at para position of phenol and para position of aniline at the end. That means this N2 pH will be attached to para position. So can I write like this? pH, this, and this is N2. So pH and N, after that it is double bond N. This will be attached to phenyl. That means N2 pH will be attached to phenyl, this phenol at para position. So coupling of this will take place at para position. Here it's also taking place at para position. Both are dyes and both are having a nitrogen group, that means azo group. So both are azo dyes, but this is known as 4-hydroxy azobenzene, and this is orange in color. That's why this is known as an orange dye. And this is known as what we call 4, not hydroxy, here it is amino, it's NH2 group. So this is 4-amino azobenzene. This is also an azo dye. Both are azo dyes, but this is yellow in color. Hence, we can simply say this is yellow dye. Now, this is very important. Have a look. If you are having both the groups and both are attached to para position with respect to each other, then what will happen? If reaction takes place in this fashion, if reaction takes place in this fashion, one in basic medium, another in acidic medium. Now tell me, let me know in the chats. In basic medium, pH N2 will couple with, benzene diazonium chloride will couple with, in basic medium, it will couple with phenol at para position, phenol at para position. But in phenol, if this is OH attached to ring, that means phenol, para position of phenol is blocked due to NH2. There is no hydrogen. Now, reaction will take place at ortho position of the phenol in basic medium. That's why product will be like this. It will be like this. Ortho position with respect to phenol, N2 pH will come. And here, in acidic medium, reaction should take place, in acidic medium, reaction should take place para with respect to NH2. Para with respect to NH2 is blocked. That's why reaction takes place at ortho to NH2. Now, N2 pH goes to ortho, but with respect to OH, here it goes to ortho, but with respect to NH2. That depends on medium, whether it is basic medium or whether it is acidic medium. Now, this is all about, this chapter, but we have few asked questions over here. Let me know whether you can solve these questions or not. First of all, have a look. NH2, NO2HCl, that means diazotization reaction. So what will be A? A will be simply like this. It will be N2Cl, having negative charge and positive. Then it is CuCN, send me a reaction. So what will happen? It will replace this N2 by cyano group. So it will be like this. Can I say Cn means C triple bond N? So its reduction will simply result in the formation of CH2NH2. That means primary amine. After that, have a look. Nitrogen is attached to sp3 hybridized carbon. When nitrogen is attached to sp3 hybridized carbon, when NH2 is attached to sp3 hybridized carbon, primary amine, on treatment with nitrous acid, simply remove this NH2 and attach OH there. That means results in the formation of C6H5, CH2 and OH. So we have to say what is the product D. Product D is C6H5, CH2OH. So this is simple question asked in, competitive examination. Now, after that, A upon reduction gives B, which on treatment with chloroform KOH gives C, which upon reduction gives this. Now, what is this? This is N-methyl aniline. That means like this. So, this is a secondary amine, but secondary amine in which N-methyl is there. Remember, it is formed by reduction of, it will be formed by reduction of isocyanide. It is formed by reduction of isocyanide. That means if I know this, I can form this product, this reactant as well. Now, have a look. This is carbylamine reaction. That means NC has been, added to this position, but starting material of carbylamine reaction is, instead of NC, we were having NH2. That means it is this one. Now tell me, NH2 is formed by reduction of what? NO2. So this is nitrobenzene. A is nitrobenzene. This is not this. This one is the nitrobenzene. So this is the what we call answer of this question. After that, which of the following reagents will convert paramethyl benzene diazonium chloride? Have a look. This is paramethyl benzene diazonium chloride. This one. Which reagent can convert this to paracresol? Cresol means CH3 and OH, but at para position, OH and CH3 should be present. Now, CH3, that means this has become OH. Now, tell me, which reagent can convert N2 to OH? That is water. That means this one. It's a very easy question. Now, next question which were asked in exam is that this has been converted to this. That means instead of this, here it is H. Which is the reagent which can replace N2 by H? There are two reagents. One is H3PO2 and water. That means hypophosphorus acid. In water, yeah, phosphenic acid in water. Second is CH3CH2OH. Have a look. CH3CH2OH is not there, so this is there, so this will be the answer. After that, next is benzene diazonium chloride on treatment with Cu2Br2. That means it is what we call Sandmeyer reaction. So first of all, it will result in the formation of bromobenzene. First will be bromobenzene. First product will be bromobenzene. Second product is bromobenzene on treatment with magnesium. Whenever you are having CX bond, magnesium will incorporate between C and X. That means it will result in the formation of Grignard's reagent, phenoxymagnesium bromide. So this is having negative charge, this is having positive charge. Now third, whenever it reacts with any acidic hydrogen containing compound, so this negative part will accept hydrogen from this, that means it will act as a base, so it will result in the formation of, it will accept hydrogen, that means it will form benzene. Now, is any product benzene? Yes. So this is our product of this reaction. So this was all about amines and benzene diazonium salts. So thank you very much to each and everyone who were there with me, and God bless you all. Now let me know, is everything clear? Thank you, Gege sir. Love Kerala. Thank you Arjun. Thank you very much. Asiba, thank you very much. Nobody. Lyra, thank you. Choti Sinha, thank you. Bhargav, thank you. Yuna Vishik, thank you. Rifka, thank you. Mubina, thank you everyone. Now my dear lovely students, this is all for today. Now we'll meet you on Saturday at 8 p.m. and that too in a very important session, that is all naming reactions. But before leaving, I would want you all to comment in comment section after ending of the session that how was today's session. So thank you and God bless you all. Good night. Take care.